What if the greatest structures ever built by human hands were never supposed to be found? Not lost by accident. Not buried by time alone. But deliberately hidden, sealed away beneath earth, ocean, and silence, because their existence changes everything we think we know about who we are and where we come from. Picture this for a moment. A researcher sits alone in a dim room, staring at a glowing satellite image on a computer screen. At first, it looks like noise, random shadows, geological clutter. But then the shapes sharpen. Lines appear where nature doesn't draw lines. Angles emerge where erosion never carves right angles. And suddenly, unmistakably, there it is, a structure. Massive. Precise. Impossible. Not marked on any map. Not listed in any textbook. And not supposed to exist at all. This is how many of the most disturbing discoveries of the last century have begun. Not with trumpets or press conferences, but with quiet disbelief. With someone leaning closer to the screen. With a long pause. And then a single thought that refuses to go away: this changes everything. For generations, we've been taught a comforting story about our past. That civilization rose slowly and clumsily from the mud. That our ancestors were simple, struggling beings who barely understood the world around them. That complex engineering, global planning, and monumental construction only became possible after thousands of years of trial and error. It's a neat story. Logical. Reassuring. But what if it isn't true? What if the timeline itself is wrong? Across the world, hidden beneath jungles, deserts, ice, and oceans, are structures so vast and so sophisticated that even modern technology would struggle to replicate them today. Megastructures built with stones weighing hundreds of tons. Cities laid out with astronomical precision. Foundations sunk so deep they defy explanation. And the most unsettling part isn't just how they were built, but when. Because according to the official story, they shouldn't exist at all. There's a strange pattern that emerges when you look closely at these discoveries. The deeper archaeologists dig, literally and figuratively, the older and more advanced the evidence becomes. Instead of a smooth upward progression of human capability, the record begins to look fractured. Discontinuous. As if something advanced existed, and then vanished. And when that pattern starts to emerge, something else happens too. Silence. Sites are reclassified. Excavations slow down. Funding dries up. Access becomes restricted for safety reasons or further study. Discoveries that should shake the world are quietly filed away, mentioned briefly in academic journals, or never discussed again. Not because they've been disproven, but because they don't fit. And fitting in matters more than truth. The idea that ancient people could build complex megastructures challenges more than archaeology. It challenges the story of progress itself. It suggests that human civilization may not be a straight line upward, but a cycle. Rise. Peak. Collapse. Forget. Begin again. If that's true, then we are not standing at the pinnacle of history. We are standing on the ruins of something older. Something powerful. Something we don't fully understand. Consider how fragile knowledge really is. We like to believe that once something is discovered, it's never lost. But history tells a different story. Entire libraries burned. Languages erased. Technologies forgotten. Civilizations that once spanned continents reduced to myths and symbols. All it takes is a single global catastrophe, a flood, a climate shift, an impact from the sky, and centuries of accumulated knowledge disappear almost overnight. Now imagine a civilization advanced enough to shape stone on a scale we still struggle to explain. Imagine it thriving tens of thousands of years ago, not with skyscrapers of steel, but with monuments designed to endure disaster. Built not for comfort, but for permanence. What would be left of us if we vanished tomorrow? Concrete crumbles. Steel rusts. Digital records disappear in an instant without power. But stone remembers. And stone is exactly what these ancient builders chose. The structures we are about to explore weren't placed randomly. They align with stars, with solstices, with planetary cycles that repeat over tens of thousands of years. That alone should give us pause. Because it implies long-term thinking on a timescale we rarely consider today. Not decades. Not centuries. But ages. Who plans for the end of the world? And why? These are not questions archaeology is comfortable asking. Because once you ask them, you are forced to confront another possibility, that our ancestors may have known something we don't. That they saw catastrophe coming. That they understood cycles of destruction written into the fabric of Earth itself. And that they built, not to dominate nature, but to survive it, or at least to leave a message behind. A message we are only now beginning to notice. What makes these discoveries even more unsettling is how often they are found by accident. A road construction project uncovers massive stone foundations far older than expected. A sonar scan meant to map the seafloor reveals geometric shapes beneath hundreds of feet of water. Satellite technology pierces jungle canopies and exposes entire cities that somehow escaped human notice for millennia. It's as if the past is no longer content to stay buried. And that raises an uncomfortable question: if these structures have been here all along, what else have we missed? Or worse, what else has been deliberately ignored? There is a quiet tension running through modern archaeology. On one side are the growing number of anomalies, structures, dates, alignments, and engineering feats that don't fit the accepted model. On the other side is an institution built on consistency, credentials, and consensus. Changing the timeline doesn't just mean updating textbooks. It means admitting that some of our most fundamental assumptions were wrong. And institutions do not like to admit that. So instead, anomalies become outliers. Advanced techniques become ritual symbolism. Precision becomes coincidence. And the bigger the mystery, the quieter the discussion becomes. But silence doesn't erase stone. The truth is, we are living in an era where technology is beginning to expose what the ground has hidden for thousands of years. LiDAR scans are peeling back forests. Deep-sea exploration is mapping the ocean floor in unprecedented detail. Ground-penetrating radar is revealing structures no one expected to find. And with each advancement, the past becomes harder to control. The old story is cracking. And through those cracks, something ancient is staring back at us. This isn't just about ruins or monuments. It's about identity. About whether humanity is a young species stumbling forward, or the inheritor of a forgotten legacy. About whether progress is inevitable, or temporary. And about whether the warnings carved into stone were meant for us. Because if advanced civilizations existed before us and were wiped out, then the question is no longer if it could happen again. The question is whether we're paying attention. As we move forward, deeper into forbidden sites and controversial discoveries, one thing becomes clear: these megastructures were not built by accident, and they were not built for us to easily understand. They demand patience, humility, and a willingness to accept that the past may be far more complex, and far more uncomfortable, than the story we've been told. And once you see the evidence, once you truly look at it without fear, there's no going back. Because the moment you accept that these structures exist, you have to ask why the world was never meant for you to find them. To understand why these discoveries are so unsettling, you first have to understand the story we've been taught to believe. Not just casually, but deeply, woven into textbooks, documentaries, museums, and classrooms around the world. It's a story so familiar that most people never think to question it. A story that feels solid, scientific, and settled. According to this official timeline, human civilization is a relatively recent experiment. For the vast majority of our existence, we are told, humans were simple hunter-gatherers, nomadic, technologically limited, and entirely at the mercy of nature. We survived by improvisation, not innovation. We learned slowly. Painfully. Progress, we're told, took tens of thousands of years. Then, around 5 to 6,000 years ago, something remarkable supposedly happened. Civilization began. Agriculture took root. Cities emerged. Writing appeared. Monumental architecture followed shortly after. And from that point forward, history moved in a steady upward climb, from stone tools to bronze, from bronze to iron, from mud brick villages to stone temples. It's a clean narrative. Elegant. Easy to teach. And that's precisely why it's so dangerous. Because clean narratives often require inconvenient details to be smoothed over, ignored, or explained away. The official timeline depends on assumptions as much as evidence, assumptions about what ancient people were capable of, assumptions about how quickly knowledge can develop, and assumptions about what kinds of civilizations are even allowed to exist in the deep past. One of the most important assumptions is this: complexity takes time. According to mainstream thinking, advanced engineering, mathematics, astronomy, and large-scale social organization must evolve slowly, layer by layer. Anything that appears too advanced, too early, is treated with suspicion. Not because it's been disproven, but because it violates expectation. And expectations quietly shape interpretation. When archaeologists excavate a site, they don't approach it as a blank slate. They bring a framework with them, an internal timeline of what should be found at a certain depth, in a certain region, from a certain period. Artifacts that fit the framework are celebrated. Those that don't are questioned, redated, or quietly sidelined. This isn't necessarily malicious. It's human. But over time, these biases harden into doctrine. Consider how dates are assigned in the first place. Radiocarbon dating, for example, is an extraordinary tool, but it's not infallible. It relies on assumptions about atmospheric conditions in the past, calibration curves, and sample integrity. It works best within certain time ranges and becomes less precise the further back you go. Yet it's often treated as definitive, even when results conflict with other evidence. And when a date emerges that challenges the accepted timeline, the instinct isn't to question the timeline, it's to question the date. Now zoom out and look at the bigger picture. According to the official model, early humans were barely capable of basic shelter, let alone massive stone construction. They lacked metal tools, advanced mathematics, written language, or centralized authority. And yet, we are asked to believe that within a relatively short span of time, these same people somehow organized thousands of workers, quarried and transported stones weighing hundreds of tons, aligned structures to celestial events, and built monuments that have survived for millennia. All without leaving behind clear evidence of the intermediate steps. No prototypes. No developmental mistakes. No obvious progression from crude to complex. It's as if civilization appears already formed. This contradiction is often glossed over by labeling ancient people as primitive but ingenious, a phrase that sounds respectful but explains nothing. Ingenuity alone doesn't account for logistical planning, mathematical precision, or the transmission of complex knowledge across generations. And this is where the timeline begins to feel less like a record, and more like a boundary. There is also a powerful psychological factor at play, the desire for linear progress. Modern society is built on the belief that we are more advanced than anything that came before us. It's comforting. It reinforces a sense of superiority and control. The idea that earlier civilizations might have reached comparable, or even greater, levels of sophistication is deeply unsettling. Because if they did, then advancement doesn't guarantee survival. The official timeline avoids this discomfort by presenting history as a steady climb, punctuated by innovation but never by total collapse. Even when civilizations fall, the narrative suggests that knowledge is preserved and passed on, leading inevitably to us. But what if that's not how history works? What if knowledge can be lost completely? What if entire technological traditions can vanish, leaving only fragments that later cultures misunderstand or mythologize? What if the past wasn't a straight line, but a series of peaks and valleys, some of them far higher than we're willing to admit? These possibilities are rarely explored in mainstream archaeology, not because they lack evidence, but because they destabilize the foundation of the field itself. Careers are built on the timeline. Entire academic disciplines depend on it. To change it isn't just to update a date, it's to rewrite everything. And rewriting everything comes at a cost. This is why, when anomalous evidence surfaces, it's often met with intense resistance. Not curiosity. Not excitement. Resistance. Skepticism that borders on dismissal. Researchers who propose older dates or more advanced ancient capabilities find themselves isolated, labeled as fringe, or accused of sensationalism. The message is subtle but clear: explore within the lines. Yet history itself refuses to stay within those lines. The deeper we look, the more cracks appear. Sites once thought to be a few thousand years old are suddenly dated much earlier. Structures assumed to be ceremonial turn out to have sophisticated engineering features. Settlements believed to be temporary show signs of long-term planning. And each time this happens, the timeline shifts, quietly. Incrementally. Without fanfare. The public is rarely told that history has changed. Textbooks lag behind discoveries by decades. Museums update exhibits slowly, if at all. The illusion of certainty remains intact, even as the foundation beneath it erodes. What we're left with is not a timeline carved in stone, but one written in pencil, revised again and again, always in the direction of greater antiquity, greater complexity, and greater mystery. And yet, the core assumption remains untouched, that advanced civilization could not exist deep in the past. That assumption is the real barrier. Because once you remove it, everything changes. Megastructures stop being anomalies and start being evidence. Myths stop being fantasies and start being distorted memories. Sudden leaps in human capability stop being miracles and start being inheritances. The official timeline is not a lie, but it is incomplete. It tells a story of survival, adaptation, and progress, but it leaves out collapse, loss, and forgetting. It shows us how we rose, but not how others may have fallen before us. And perhaps that omission isn't accidental. Because a timeline that admits repeated rises and falls would force us to confront an uncomfortable truth: that civilization is fragile. That intelligence doesn't equal wisdom. And that being advanced doesn't make us immune to the same forces that erased those who came before. As we move deeper into the evidence, into the structures, the alignments, the engineering feats that refuse to fit neatly into accepted history, the question shifts from what happened to why we're so afraid to admit it happened at all. The official timeline may feel solid. But under pressure, even the most carefully constructed narratives can fracture. And when they do, what emerges from beneath them is rarely what we expect. The stone rises from the earth like a monument to a forgotten genius, its edges so sharp that even modern masons would struggle to recreate them, its surface polished with a precision that defies human memory. What is most unsettling about these ancient structures is not merely their scale, but the level of engineering sophistication they reveal, sophistication that seems entirely out of place for the civilizations that supposedly built them. Across deserts, jungles, and mountains, we find megalithic complexes carved with exacting angles, massive blocks fitted together so tightly that even a single sheet of paper cannot slip between them. The more closely scientists examine these formations, the less plausible the conventional explanations become. We are forced to ask a question that few are willing to consider: how could people with supposedly primitive tools achieve such perfection? At sites like Puma Punku in Bolivia, entire platforms are constructed from stones weighing dozens, sometimes hundreds, of tons. These stones are not only massive, they are intricately carved with geometric shapes that align across large distances with a precision comparable to modern CAD designs. Holes drilled through the blocks are perfectly cylindrical, some several feet deep, and show signs of workmanship that defy the limits of copper and bronze tools that would have been available at the time. Scholars have long speculated about how these stones were moved, cut, and positioned, but every proposed method strains credibility. Ramps, levers, and sheer manpower could account for some movement, but they cannot account for the exactitude observed in the joints and angles, nor the apparent knowledge of complex mathematics embedded in the layouts. The precision becomes even more remarkable when we consider the scale of the work. Moving a single block of this size would have been a monumental feat for any society, yet entire complexes were constructed using hundreds of such blocks, each placed with meticulous care. In many cases, these structures span hundreds of meters, with multiple terraces, canals, and platforms aligned along precise axes. The sheer coordination required to execute such projects implies a level of social organization, technical understanding, and long-term planning that the official historical narrative simply cannot accommodate. It forces us to reconsider the capabilities of these ancient builders, suggesting that their understanding of physics, geometry, and logistics was far more advanced than previously thought. Equally confounding is the question of tools and methods. Archaeologists have found little evidence of the metal implements that would logically be required to produce such clean cuts and perfect fittings. Copper chisels and stone hammers leave marks inconsistent with what we see in these sites. Some researchers have suggested that lost technologies or techniques, long forgotten and undocumented, may have been employed. Others propose that the ancients understood principles of materials science that allowed them to manipulate stone in ways modern engineers are still struggling to replicate. Every theory raises further questions. If such methods existed, why did they disappear? How could a society capable of such construction leave so few traces of its knowledge? The alignment of these structures adds another layer of mystery. Across continents, from the Andes to the deserts of Egypt, we find evidence that megastructures were deliberately oriented according to astronomical phenomena. Stones and platforms align with solstices, equinoxes, and even the movements of distant stars. This suggests a deep understanding of celestial mechanics and implies that the builders were not only skilled engineers but also sophisticated astronomers. The precision required to achieve such alignments over centuries, or even millennia, demonstrates foresight and long-term planning on a scale that most historians find difficult to imagine. The evidence challenges the assumption that these early societies were primarily concerned with survival and ritual, hinting at knowledge and intent that reach far beyond the ordinary. What is perhaps most disturbing is the recurrence of these features in disparate locations. Across the globe, civilizations separated by thousands of miles, with no known contact, produce structures that exhibit similar technical sophistication, precise alignment, and geometric perfection. The probability that these similarities are coincidental strains credulity. Some theorists suggest a shared ancient knowledge, passed down from a common source or civilization that predated our accepted history. Others argue for a convergence of human ingenuity under similar conditions, though the level of similarity often defies the logic of independent invention. The repeated appearance of advanced construction in multiple, isolated societies implies that we may be looking at the remnants of something far older, something intentionally concealed by the erosion of time and the selective recording of history. Adding to the sense of unease is the context in which these structures were found. Many lie buried beneath layers of sediment, silt, or jungle, effectively hidden from discovery for thousands of years. Some were only revealed accidentally through modern excavation techniques, aerial photography, or satellite imaging. Each discovery seems to arrive like a whisper from the past, hinting at knowledge that was once widespread but has been lost. The patterns, alignments, and constructions challenge not only our understanding of history but also our perception of human capability. It raises the possibility that our ancestors may have been far more sophisticated than the history books allow, and that much of what we accept as a beginning is actually a reconstruction built on fragments of a much larger, older truth. The emotional impact of these discoveries cannot be overstated. Standing before a massive, precisely cut stone, aligned to the stars and fitted perfectly with its neighbors, one cannot help but feel a sense of awe, and a sense of unease. There is a tension between admiration and discomfort, a realization that our current understanding of human history may be incomplete or even intentionally sanitized. These structures do more than impress with their technical mastery, they provoke existential questions about the continuity of human knowledge, the rise and fall of civilizations, and the forces, whether natural or deliberate, that have shaped the record we inherit. This tension becomes acute when comparing these ancient feats with modern construction. Today, with cranes, explosives, and advanced machinery, replicating these stones would be difficult, expensive, and time-consuming. Yet these achievements were completed in eras purportedly devoid of such technology. The implication is unavoidable: either the civilizations of the past were far more capable than we have been taught, or our understanding of the timeline itself is flawed. Both possibilities are uncomfortable because they challenge fundamental assumptions about progress, capability, and the uniqueness of the modern world. In essence, these megastructures act as silent witnesses to a lost sophistication. They suggest a past where engineering, astronomy, mathematics, and social organization were combined in ways that modern society struggles to replicate. They demand not only technical analysis but also a willingness to question the official narrative, to acknowledge that our ancestors may have been part of a far more complex human story than we have allowed ourselves to believe. Each stone, each alignment, each carefully constructed platform whispers of knowledge that refuses to be contained by the limits of textbooks or academic dogma. And so we are confronted with a profound mystery: how could humans, supposedly primitive and isolated, produce works that rival our own in precision and scale? What knowledge has been lost to time, and what forces conspire to erase it from collective memory? As we explore these structures, the answers remain elusive, but the questions themselves are enough to unsettle the foundation of everything we think we know. The past, it seems, is not a simple story of progression, but a landscape filled with anomalies, secrets, and achievements that continue to challenge and inspire, demanding that we look closer, think deeper, and question everything we have been told. Long before modern technology began to peel back the layers of time, some of the earliest archaeologists stumbled upon evidence that suggested the story of humanity might be far more complicated than textbooks claimed. In the late 19th and early 20th centuries, researchers began uncovering artifacts and sites that did not fit neatly into the accepted chronological framework. Massive stone constructions, anomalous tools, and inexplicably advanced layouts appeared in locations that conventional history had long dismissed as the domain of primitive peoples. What made these finds extraordinary was not only their age but the sophistication they exhibited, sophistication that no one at the time could reconcile with the prevailing notion of linear human progress. One of the earliest and most striking examples comes from South America. Explorers and local guides described vast stone platforms and terraces that seemed too precise and too large to have been created with rudimentary tools. Archaeologists attempting to study these sites were immediately confronted with questions they were ill-prepared to answer. How could societies lacking metal tools and written records have moved and carved stones weighing dozens or hundreds of tons? The conventional explanations offered, slaves, sheer manpower, or natural forces, felt inadequate in the face of precise engineering, intricate joints, and symmetrical designs that spanned vast areas. The discomfort these anomalies caused often led scholars to minimize or ignore the evidence entirely, labeling it as unverified or improbable. Similarly, in Egypt, early excavations in the 19th century unearthed structures and artifacts that seemed to predate known dynasties. The most famous example, of course, is the Great Pyramid of Giza. While mainstream archaeology attempted to situate it within the 4th dynasty, inconsistencies in construction methods, tool marks, and alignment with celestial phenomena raised eyebrows. Early researchers noted that the precision of the pyramid's layout, the scale of the stones, and the apparent mathematical knowledge embedded in the architecture could not be easily explained by the known capabilities of the time. Journals and personal correspondences from these archaeologists reveal a mixture of awe and frustration, as they struggled to reconcile what they were witnessing with the accepted historical narrative. Yet, despite this, their findings were often downplayed or dismissed as exaggeration or misinterpretation. Across the globe, similar patterns emerged. In the islands of the Pacific, massive stone statues and ceremonial platforms, such as those on Easter Island, presented an equally confounding challenge. Local lore spoke of ancestors with extraordinary powers, capable of moving colossal stone figures without modern machinery. Early researchers documented the precision and scale but found no evidence of the technologies that would have made such feats possible. Despite the anomalies, reports were often tempered with skepticism, and many discoveries were relegated to footnotes in academic discourse rather than fully explored. The phenomenon was not confined to grand monuments. Small but equally perplexing artifacts surfaced, such as tools with wear patterns that suggested advanced metallurgy, carvings that encoded astronomical knowledge, or devices that seemed to serve purposes entirely unknown to modern science. Each discovery created a ripple of cognitive dissonance. The evidence could not be easily explained by the prevailing timeline, and yet the evidence persisted. Scholars who attempted to pursue these questions often encountered resistance from peers or funding bodies. Some were warned that pursuing unconventional interpretations could damage reputations or result in professional isolation. In many cases, the anomalies were catalogued but never fully studied, effectively erasing them from public awareness. A recurring theme in these early discoveries was the sense that human history was far older and more complex than anyone had acknowledged. Sites appeared in unexpected regions, suggesting that advanced capabilities were not limited to one civilization or culture. In South America, Africa, and Asia, structures appeared that seemed to predate known societies by thousands of years, yet they demonstrated technical sophistication comparable to, or exceeding, that of their purported successors. The implication was staggering: either civilizations rose and fell multiple times before the recorded history we know, or our understanding of technological development was fundamentally flawed. In either scenario, the conventional timeline was incomplete at best, and misleading at worst. The reaction to these early anomalies was often a mixture of fear, skepticism, and professional caution. Journals and conference presentations reveal that some scholars quietly acknowledged the significance of what they found but chose to frame it in conservative terms. Proto-civilization, or precursor culture, became convenient labels, allowing researchers to describe complexity without challenging the overarching historical narrative. Meanwhile, sensationalized accounts circulated in newspapers and popular magazines, often exaggerated or misinterpreted, feeding the public imagination but frustrating serious scholarship. This duality, between cautious academic acknowledgement and public fascination, set the stage for a persistent tension that continues to this day: the desire to explore forbidden truths versus the institutional pressure to conform to a safe, conventional story. In some cases, entire sites were effectively lost to history because of this tension. Political instability, restricted access, and lack of funding meant that certain locations remained unexplored for decades. When excavations did occur, they were sometimes limited or incomplete, leaving tantalizing fragments of evidence without the context necessary to fully understand them. Satellite imagery and modern remote sensing technologies have since revealed structures that early researchers could only dream of documenting, confirming that many of the most important clues were overlooked or underestimated. The early discoveries, while sporadic and incomplete, nonetheless created an undeniable pattern. Humanity's past is littered with evidence of advanced engineering, intricate design, and purposeful construction that cannot be easily reconciled with conventional timelines. These early anomalies also raised uncomfortable questions about intent and purpose. The scale and precision of these constructions suggest planning, coordination, and knowledge that would have required generational expertise. This implies not just temporary settlements or ritual monuments but long-term, organized societies capable of complex logistics and foresight. Yet the official story, emphasizing gradual technological progress, provides no satisfying explanation for these phenomena. Instead, the evidence was often labeled as isolated anomalies or dismissed as misdated relics, creating a dissonance between what could be observed and what could be accepted. Ultimately, the early discoveries that were ignored or minimized form a foundation for the growing body of evidence that challenges our understanding of human history today. They illustrate that, long before satellites, carbon dating, and modern excavation techniques, there were clues scattered across the globe hinting at a more complex and ancient civilization. These clues were often buried, dismissed, or quietly shelved, leaving us with fragments of a story that is far larger than the one we have been taught. The work of those early archaeologists, their notes, sketches, and photographs, now serve as a haunting reminder: the past is not always what it seems, and the truth about humanity's origins may have been hiding in plain sight all along, waiting for the moment when someone would dare to ask the questions that others were too afraid to consider. Long before satellites and ground-penetrating radar, before excavations and carbon dating, maps themselves offered a glimpse into a past that mainstream history refuses to acknowledge. These maps, created centuries ago, depict coastlines, continents, and geographical features with a precision that seems impossible for the time in which they were drawn. Some even show areas that modern science claims were uncharted or covered by ice during the last ice age. The very existence of these maps challenges the accepted narrative of human knowledge and suggests that there was once a level of understanding far greater than we have been taught. They hint at a lost civilization whose influence stretched across the globe, leaving traces that scholars have long struggled to explain. One of the most famous examples is the Piri Reis map, drawn in 1513 by an Ottoman admiral and cartographer. While it gained attention primarily for its detailed depiction of the coasts of South America and Africa, closer inspection reveals something far more perplexing. Portions of the map appear to show the northern coast of Antarctica, completely free of ice. This is troubling because Antarctica was not officially discovered until centuries later, and according to glaciological studies, the ice sheet covering it has been in place for tens of thousands of years. The map itself was supposedly compiled from older sources, many of which have been lost to time, yet it contains accurate measurements and coastlines that modern cartographers would struggle to reproduce without advanced surveying tools. The implication is unsettling: knowledge existed in the past that has since disappeared, knowledge capable of mapping the world with remarkable accuracy. The Piri Reis map is not an isolated case. Across Europe and the Middle East, other maps from antiquity and the early modern period display similar anomalies. The Orontius Phineas map, created in the 16th century, also depicts Antarctica with surprising detail, again showing areas without ice that should have been inaccessible to explorers of that era. Similarly, Chinese and Arab cartographers produced charts with coastlines, islands, and inland features that align closely with modern measurements, yet there is no historical record of how they obtained such information. These maps collectively suggest that there may have been a continuity of knowledge, passed down through lost civilizations, that was erased from mainstream history yet preserved in select records. What makes these maps particularly compelling is not just their accuracy, but the subtle understanding of geography and topography they reveal. Rivers, mountains, and coastal contours are depicted with remarkable fidelity, and in some cases, the relative distances between continents are astonishingly precise. Scholars have argued that such measurements would have required tools and methods unavailable to known civilizations of the time. Navigation by celestial observation alone cannot account for the exactitudes found in these charts, suggesting that survey techniques or empirical knowledge from a prior advanced culture were involved. It is as if the maps themselves are whispers from a forgotten age, pointing to a civilization capable of understanding the Earth with a sophistication that should have been impossible. Equally intriguing is the repetition of anomalies across different maps and cultures. Despite originating from various regions, Ottoman, European, Arab, and Asian, these charts share surprising consistencies. Coastlines correspond, certain islands appear in multiple maps despite being unknown at the time, and peculiar features like Antarctica or remote archipelagos are depicted with accuracy far beyond what contemporary explorers could have achieved. This cross-cultural convergence hints at the possibility of a shared body of knowledge, perhaps passed down from a civilization that predates recorded history. If true, it would mean that the past was far more interconnected than we are willing to admit, and that knowledge once traveled across continents in ways that have been all but erased from memory. The implications extend beyond geography. These maps force us to confront uncomfortable questions about the transmission and loss of knowledge. How could advanced mapping techniques disappear entirely? How could civilizations capable of such understanding vanish without leaving a comprehensive record? The very existence of these maps undermines the narrative of a simple, linear progression of human capability, suggesting instead a more complex history punctuated by rise, peak, and catastrophic decline. In this light, cartography becomes more than a tool for navigation, it becomes a silent witness to civilizations we can barely imagine, preserved in fragments that survived the erosion of time, war, and cultural upheaval. There is also a psychological dimension to consider. Maps are, at their core, representations of understanding. They embody how humans conceptualize space, distance, and the world itself. That such accurate maps existed so long ago implies a worldview vastly different from what history textbooks portray. It suggests that ancient peoples may have possessed global awareness, a capacity to measure and record distant lands with sophistication that modern scholars assumed impossible. If these maps reflect reality, they point to a continuity of intelligence that has been systematically underestimated or erased. Every coastline, every island, every contour line becomes a clue pointing toward a civilization that understood the world on a scale we are only beginning to comprehend. The very act of creating a map demands a combination of observation, calculation, and record-keeping. In an era without satellites, GPS, or advanced instruments, achieving the precision seen in maps like the Piri-Reis chart would have required careful measurement, long-term observation, and a comprehensive understanding of geography. These are not the haphazard sketches of traders or travelers, they are deliberate constructions, crafted with a purpose and an awareness of the world's dimensions. They suggest that the civilizations responsible for these maps were capable not only of advanced engineering and architecture but also of sophisticated data collection, analysis, and communication. In other words, the knowledge embedded in these maps is consistent with the kind of advanced thinking that also underlies the construction of the megastructures scattered across the globe. It is no coincidence that the areas depicted with surprising accuracy on these maps often correspond to sites of mysterious ancient construction. The coasts of South America, Antarctica, and the Middle East, all regions appearing with precision in centuries-old maps, are home to structures and ruins that defy conventional explanation. The alignment is eerie, suggesting that knowledge of these sites, their placement, and their significance was known long before the modern era. The maps do not merely chart geography, they hint at a network of understanding, a template of human achievement that transcends the limitations of recorded history. Ultimately, the evidence of these maps challenges the very foundations of what we consider historical fact. They demand that we reconsider the timeline of human knowledge, the distribution of intelligence, and the capabilities of civilizations long erased from our collective memory. They force us to accept the possibility that what we believe about the past is provisional, incomplete, and shaped as much by what we are allowed to know as by what actually occurred. Each line on these ancient charts becomes a question, each measurement a provocation, reminding us that the world as we understand it may be only a fraction of the story. The maps suggest a past rich with sophistication, global awareness, and forgotten genius, evidence that humanity's story is far deeper, far more intricate, and far more mysterious than we have ever been taught. Beneath the surface of deserts, jungles, and fertile plains lie secrets that have remained hidden for millennia, concealed by earth, vegetation, and the passage of time. These are not small artifacts or scattered remnants, but entire complexes, buried cities, massive platforms, subterranean tunnels, that defy conventional understanding of ancient engineering. Unlike surface monuments that can be observed and studied openly, these hidden structures were deliberately or naturally covered, leaving only traces for the most attentive eyes to discover. What makes these finds extraordinary is not merely their size, but the sophistication, purpose, and planning evident in every aspect of their construction. Each layer of earth removed reveals a level of design that seems incompatible with the supposed technological limitations of the civilizations credited with their creation. Archaeologists first encountered the mystery of buried giants through incidental discoveries. A plow strikes a massive stone foundation in a South American field. Construction crews in the Middle East uncover a hidden platform beneath layers of sediment, sonar scans reveal submerged walls and streets beneath coastal waters. Each instance initially appears isolated, almost accidental, yet patterns emerge as more sites are revealed. The structures are not random, they exhibit organization, alignment, and intentionality. Long corridors, perfectly leveled terraces, and intricate layouts suggest that their builders possessed both the knowledge and the foresight to plan on a monumental scale. Unlike typical ruins that collapse over time, these buried giants seem to have been intentionally preserved, hidden, or forgotten, waiting for the modern world to uncover them. The dimensions of these structures are staggering. Massive stones are cut and fitted with precision so fine that even a razor blade cannot slip between them. Some subterranean complexes contain chambers extending hundreds of meters below the surface, with walls aligned according to celestial phenomena or cardinal points. The engineering challenges alone, excavation, transportation, and precise placement, suggest an expertise that would rival modern construction. When considered alongside the supposed simplicity of the societies of the time, the existence of such structures raises profound questions. How could people without advanced machinery, without documented knowledge of physics or engineering, accomplish feats that continue to baffle modern experts? The very survival of these constructions, despite natural erosion, seismic activity, and centuries of neglect, adds to the mystery. One of the most compelling examples comes from South America, where extensive subterranean networks have been discovered beneath the Andes and Amazon basin. Tunnels, canals, and chambers interconnect in ways that indicate intentional design, not accidental formation. Some passages are aligned to rivers and water sources, suggesting knowledge of hydraulics, while others are positioned to take advantage of structural geology, indicating a sophisticated understanding of the terrain. The scale of these networks implies coordinated labor, advanced planning, and knowledge passed down across generations. Yet these societies supposedly lacked formal engineering institutions, written records, or advanced tools. Reconciling these facts challenges the conventional timeline and forces scholars to consider alternative explanations. In Asia, similar discoveries reinforce the global nature of the phenomenon. Hidden platforms and subterranean complexes in regions of India, China, and the Middle East display remarkable geometric regularity, precise leveling, and careful orientation. Some of these sites were only revealed through remote sensing, LiDAR scanning, and ground-penetrating radar, technologies unavailable to early explorers. The findings suggest that human ingenuity had reached heights far beyond what mainstream history credits to the periods in question. More intriguingly, the recurring architectural motifs, construction techniques, and alignments across continents imply a level of knowledge exchange or cultural continuity that remains unexplained. These buried giants do not exist in isolation, they form part of a hidden network of advanced human endeavor that defies standard historical interpretation. Submerged cities add an additional layer of mystery. Off the coasts of India, Japan, and the Americas, sonar and diving expeditions have revealed entire settlements beneath the waves. Streets, foundations, and walls of unknown age lie intact beneath hundreds of meters of water, often corresponding with times when sea levels were significantly lower. These discoveries challenge assumptions about the antiquity of human habitation, suggesting that entire civilizations may have existed long before recorded history and were subsequently engulfed by rising seas or cataclysmic events. The submerged sites often mirror the complexity seen in terrestrial buried giants, including aligned streets, terraced platforms, and water management systems, pointing to deliberate, intelligent planning rather than random accumulation. The implications of these hidden structures extend beyond architecture and engineering, they speak to social organization, cultural sophistication, and long-term strategy. The scale and complexity of the buried giants suggest hierarchical societies capable of mobilizing large labor forces, coordinating multi-generational projects, and preserving knowledge over centuries. Yet the absence of written records or surviving technologies poses a paradox. Either this knowledge was lost due to disaster, neglect, or deliberate concealment, or our understanding of the chronological and cultural framework of human history is incomplete. Either scenario forces a re-evaluation of what humanity was capable of in eras we thought were primitive. The process of discovering these structures often evokes a sense of awe and unease. Excavating a buried platform, uncovering a hidden chamber, or mapping a submerged street is not merely a technical exercise, it is a confrontation with a past that challenges everything we think we know. The structures are silent witnesses, communicating through their very existence that the human story is far older and more complex than official narratives admit. Every stone, every tunnel, and every chamber prompts questions that have no easy answers. Who built this? How did they achieve such precision? Why was it hidden? And what does it mean for the civilizations we consider foundational to our history? Modern technology has accelerated the discovery of buried giants, revealing that these are not isolated anomalies but part of a vast, interconnected pattern. LiDAR scanning in dense jungles has exposed previously invisible city layouts, complete with streets, plazas, and ceremonial structures. Ground-penetrating radar has mapped underground networks spanning hundreds of meters, revealing corridors and chambers whose purpose remains speculative but clearly intentional. Even satellite imagery has detected geometric anomalies in the landscape that correspond to human construction, now buried under centuries of sediment or vegetation. These tools are peeling back layers of history, showing that much of human achievement has been deliberately or inadvertently concealed beneath the earth. What is perhaps most striking is the realization that these hidden structures often share characteristics with better-known monuments above ground. Terracing, precise stone fitting, alignment with celestial events, and water management are recurring themes. This suggests not only technical continuity but also shared cultural principles or purposes. The buried giants, whether underground or submerged, represent a level of sophistication that modern society can recognize and admire, yet they are difficult to fully comprehend within the limitations of the conventional historical framework. They hint at civilizations whose accomplishments surpass what is recorded in our textbooks, civilizations whose influence may have been global and whose memory has been obscured over millennia. Ultimately, these subterranean and hidden structures compel a re-evaluation of the human past. They are not merely archaeological curiosities, they are evidence of knowledge, skill, and ambition that challenges linear notions of progress and civilization. Each excavation, scan, or dive reveals another piece of a puzzle that has been hidden for thousands of years, inviting us to reconsider the capabilities of our ancestors. The existence of buried giants suggests that humanity's story is far more complex, far older, and far more interconnected than we have been taught, and it demands that we approach the past with humility, curiosity, and an open mind. For beneath our feet and beneath the waves lies a record of ingenuity that refuses to be forgotten, waiting for those willing to uncover it and confront the unsettling truths it contains. Beneath the waves of oceans and seas, hidden from human eyes for millennia, lie cities and settlements that challenge everything we think we know about our past. These sunken civilizations are not mere myths or the stuff of legend, they are tangible remnants of societies that flourished long before recorded history and were swallowed by rising seas, tectonic upheavals, or cataclysmic events. The very existence of these submerged sites raises profound questions about the antiquity and sophistication of human civilization. How could communities capable of building complex urban centers, planning infrastructure, and organizing labor vanish almost entirely beneath the water? And if they existed, why has so little of their story survived above ground? The discovery of these underwater cities often begins unexpectedly. Sonar scans conducted for commercial or scientific purposes frequently reveal geometric patterns on the ocean floor that are highly unlikely to be the result of natural formations. Straight lines, right angles, and regular spacing suggest deliberate human construction. In some cases, divers have been able to explore these structures directly, encountering walls, terraces, and roads preserved beneath layers of sediment. These remnants are frequently accompanied by artifacts, tools, pottery, carvings, that, when dated, suggest ages far beyond the accepted timeline of human development in the region. Each find challenges the conventional chronology and forces a reconsideration of when and how humans first achieved complex urban planning. One of the most compelling examples comes from the coasts of Japan, where submerged stone formations, terraces, and pavements have been found off the shore of Yonaguni. This site, lying dozens of meters below the sea surface, contains what appear to be monumental terraces, stairways, and large carved stones arranged in patterns that suggest deliberate construction. While skeptics argue that natural processes could account for some of the shapes, the precision and alignment of many features indicate intentional design. Geological studies suggest that the site became submerged at least 10,000 years ago, long before the civilization known to have inhabited the region, suggesting the possibility of a lost culture that predates recorded history by millennia. Similarly, off the coast of India, researchers have documented underwater ruins along the Gulf of Khumbat. Here, sonar surveys have revealed city-like layouts with roads, walls, and foundations extending for kilometers beneath the seabed. Carbon dating of recovered artifacts points to a period far earlier than the Indus Valley Civilization, which is traditionally considered one of the earliest urban societies in the region. The discovery challenges long-held assumptions about the origins of urbanization in South Asia, suggesting that advanced city building predates the civilizations previously credited with such achievements. Yet, despite the significance, much of this research remains controversial, underfunded, or unacknowledged, reflecting the discomfort that such findings provoke within mainstream archaeology. The existence of submerged civilizations is not limited to Asia. Off the coasts of the Americas, researchers have identified submerged structures near the Yucatan Peninsula and along the Atlantic seaboard. These sites often feature geometric formations, stone alignments, and remnants of harbors or canals that suggest sophisticated engineering. Rising sea levels at the end of the last ice age, around 12,000 years ago, would have inundated low-lying coastal settlements, erasing entire civilizations from the landscape. The pattern is global. Rising oceans conceal entire cities, leaving only partial evidence to be discovered thousands of years later. The submersion of these cities provides a chilling reminder of the fragility of human achievement and the impermanence of what we assume to be permanent. The technological implications of these underwater sites are equally significant. Constructing urban centers in coastal areas requires knowledge of hydrology, materials that can withstand water and erosion, and architectural planning capable of addressing environmental challenges. The sophistication observed in some of these submerged sites suggests that the builders possessed knowledge of engineering, water management, and urban planning comparable to, or in some cases exceeding, what is documented in later civilizations. That this knowledge has been lost, leaving behind only remnants now hidden beneath the waves, raises profound questions about the continuity of human understanding and the fragility of complex societies. In addition to architectural and engineering prowess, the submerged sites hint at cultural and ceremonial significance. Some underwater structures appear to align with astronomical phenomena, such as solstices or equinoxes, suggesting that these societies possessed advanced knowledge of celestial movements. Carvings and artifacts indicate social stratification, ritual practices, and trade networks that extended far beyond the immediate region. The evidence paints a picture of societies that were highly organized, technologically adept, and culturally rich, attributes that contradict the notion of prehistoric humanity as exclusively primitive or unsophisticated. The existence of submerged civilizations also forces a re-evaluation of the geological and climatic history of the planet. Many of these sites were above water at the time of their construction, implying that dramatic sea level rises occurred within relatively short geological periods. Events such as melting ice sheets, catastrophic floods, or tectonic shifts could have submerged entire cities, effectively erasing them from history. This adds a layer of complexity to our understanding of prehistoric human development, as civilizations could have risen, flourished, and disappeared long before the timelines established by conventional archaeology. It also raises the possibility that myths of floods and lost lands, found in cultures worldwide, may be rooted in collective memories of these catastrophic events. Despite their significance, submerged civilizations are often marginalized in mainstream scholarship. The difficulty of accessing underwater sites, combined with the challenge of dating structures accurately, makes research expensive and technically demanding. Moreover, the implications of these discoveries are deeply unsettling. They suggest that humanity's recorded history may be only a fraction of the full story, and that highly advanced societies existed long before the civilizations traditionally credited with human progress. As a result, much of the research remains on the periphery, leaving tantalizing glimpses of the past that are difficult to fully interpret or publicize. Yet the evidence continues to accumulate. As technology advances, sonar mapping, underwater drones, and deep-sea exploration are revealing structures of increasing complexity and antiquity. Entire networks of streets, plazas, and foundations, previously hidden beneath sediment or water, are now being documented with unprecedented detail. Each new discovery adds weight to the argument that human civilization is far older and more sophisticated than the conventional narrative allows. Moreover, the global distribution of these sites, from Japan to India, from the Americas to the Mediterranean, suggests that advanced maritime cultures existed across continents, connected perhaps by knowledge, migration, or parallel development. The sheer scale of submerged settlements implies an intelligence capable of long-term planning and environmental adaptation, challenging assumptions about prehistoric human capability. The emotional impact of encountering these sunken civilizations cannot be overstated. To descend into a submerged city, to see terraces, walls, and streets preserved beneath layers of water and silt, is to confront a past that is at once awe-inspiring and profoundly unsettling. These sites remind us that human ingenuity is not a modern invention and that our ancestors may have achieved feats far beyond what history acknowledges. They also serve as a stark warning of the impermanence of human accomplishments. Civilizations that seem eternal can vanish beneath the waves, leaving only whispers of their former glory. Each sunken city is both a marvel and a mystery, challenging our understanding of history and compelling us to ask difficult questions about what has been lost and why. Ultimately, the study of submerged civilizations forces a reconsideration of the narrative of human development. These cities demonstrate that advanced societies existed long before the rise of recognized civilizations, that they were capable of complex engineering, urban planning, and astronomical observation, and that they could be almost entirely erased by natural forces. The discoveries compel us to look beyond the traditional boundaries of archaeology and history, to consider that our knowledge of humanity's past is incomplete, and that the truth may lie hidden beneath the oceans, waiting to be uncovered. The sunken civilizations are silent witnesses to a forgotten age, reminding us that the history we have inherited may be only a fraction of the story, and that the human journey is far older, more intricate, and far more mysterious than we have been led to believe. Across the globe, the discovery of megastructures challenges the very notion of what ancient humans were capable of, forcing a reconsideration of the origins of engineering, mathematics, and monumental architecture. Among the most enigmatic of these structures are the great stone formations found in South America, Africa, and Asia, whose sheer scale and precision seem almost impossible to reconcile with the tools and techniques that conventional history attributes to their creators. Unlike smaller constructions or ritual monuments, these megalithic edifices display deliberate design, advanced understanding of geometry, and a mastery of materials that suggests a level of sophistication far beyond the presumed technological capabilities of early civilizations. They compel us to ask unsettling questions: who built them, how were they constructed, and what purpose did they serve that justified such immense labor and planning? In South America, the ruins of Puma Punku and Tiwanaku in Bolivia present some of the clearest examples of this advanced ancient engineering. At Puma Punku, massive stone blocks, some weighing more than 100 tons, are fitted together with astonishing precision. The surfaces are smoothed and cut with exacting angles, creating joints so tight that even a knife blade cannot be inserted between them. Holes and channels carved into the stone suggest the use of tools and techniques far more sophisticated than what copper or bronze implements could have produced at the time. The layout of the site itself, with terraces, platforms, and interlocking structures, indicates a mastery of planning and logistics, hinting at a society capable of coordinating large-scale projects across generations. These features challenge the conventional narrative, which depicts early South American societies as technologically primitive and incapable of producing such feats. Further north, in the Egyptian deserts, the Great Pyramid of Giza and surrounding complexes offer another window into ancient megastructures. Scholars have long marveled at the precision with which the pyramid was aligned to the cardinal points, the scale of the stone blocks used, and the architectural knowledge required to create internal chambers and passageways without modern engineering equipment. Even the logistics of quarrying, transporting, and assembling such massive stones remains a topic of debate. While conventional explanations rely on ramps, levers, and massive labor forces, these theories fail to account fully for the geometric perfection, precise leveling, and astronomical alignment inherent in the design. The pyramids suggest an understanding of mathematics, geometry, and celestial cycles that seems incongruent with the assumed capabilities of the society that built them. In Asia, particularly in the Indian subcontinent and China, similar megastructures demonstrate comparable sophistication. Monolithic carvings, massive stone platforms, and intricately aligned temples indicate a deep understanding of engineering and aesthetics. Many of these constructions are aligned with astronomical events, showing a sophisticated knowledge of solar and lunar cycles, as well as the movement of planets and stars. The effort required to move, carve, and position these massive stones implies not only technical skill but also a highly organized social structure capable of sustaining long-term projects. The similarity of techniques and alignments across distant continents raises the possibility that either knowledge was transmitted between cultures in ways we do not yet understand or that there existed a common, highly advanced precursor civilization whose influence spanned vast regions of the globe. The question of how these structures were built is one of the most persistent mysteries. Conventional archaeology assumes that early civilizations relied on simple tools and brute force. But the precision and scale observed in these sites strain the credibility of such explanations. Holes drilled with perfect circularity, blocks cut with millimeter accuracy, and stones weighing tens or hundreds of tons moved over considerable distances all suggest that the builders possessed not only sophisticated knowledge but also technology that has been lost to history. Some researchers speculate about advanced tools, methods of stone softening, or forgotten engineering techniques, yet definitive answers remain elusive. The lack of records or artifacts directly explaining these methods only deepens the enigma. The purpose of these megastructures adds another layer of intrigue. Many of the sites show alignment with celestial events such as solstices, equinoxes, or the positions of specific stars, implying that they served as observatories, ceremonial centers, or calendars. Others, like the submerged sites discovered off coasts worldwide, indicate urban planning and water management systems, suggesting practical applications alongside ritual or symbolic purposes. The combination of technical sophistication and symbolic meaning indicates that these structures were designed with both functional and spiritual intentions, reflecting a worldview in which architecture, astronomy, and society were deeply intertwined. This holistic approach to construction challenges the compartmentalized view of ancient societies as technologically capable in some areas but intellectually primitive in others. Another aspect that makes these megastructures so compelling is their durability. Many of them have withstood millennia of earthquakes, floods, erosion, and human activity, suggesting that their builders understood not only the aesthetic and functional aspects of construction but also the principles of stability and longevity. The alignment, placement, and interlocking of massive stones, combined with careful leveling and foundation work, reveal an engineering knowledge that anticipates modern principles of architecture. The endurance of these structures serves as a silent testimony to the intelligence, foresight, and ambition of their creators. The global distribution of these structures raises profound questions about the nature of early human civilization. From South America to Egypt, from India to China, the similarities in construction techniques, geometric precision, and celestial alignment suggest either parallel development under similar environmental pressures or a transmission of knowledge that predates recorded history. This raises the possibility of a lost global civilization, or at least widespread networks of knowledge that existed far earlier than previously recognized. Such a hypothesis, while controversial, cannot be dismissed outright in light of the physical evidence, which continues to accumulate through modern archaeological, geological, and remote sensing technologies. The implications of these discoveries extend beyond archaeology and into our understanding of human history itself. If ancient humans possessed capabilities that rival or even exceed what we have long assumed, then the timeline of technological and cultural development must be reconsidered. The idea that humanity's intellectual and engineering achievements are strictly cumulative, building slowly and steadily from primitive beginnings, is challenged by evidence of sudden, advanced construction across multiple continents. The megastructures suggest that ancient humans were capable of feats requiring high levels of coordination, knowledge, and innovation, potentially indicating that advanced civilizations existed long before the ones recorded in historical texts. Emotionally and psychologically, these megastructures evoke a sense of awe and unease. Standing before a massive, precisely cut stone, perfectly aligned with the stars, one cannot help but feel both admiration for human ingenuity and disquiet at the realization that much of this knowledge has been lost. There is a tension between the accomplishments of the past and the assumptions of the present, a reminder that human history may be far deeper and more complex than the narrative we have been taught. These structures are not merely relics, they are messages from a past that refuses to be ignored, challenging us to reconsider who we are, where we come from, and what our ancestors were capable of achieving. Ultimately, these global megastructures compel a reassessment of the story of civilization. They suggest that advanced knowledge, engineering skill, and social organization were present far earlier than previously believed and that this knowledge may have been widespread across the ancient world. The scale, precision, and distribution of these structures indicate that humanity's past is filled with achievements that defy conventional timelines, challenging the assumption that early humans were simple, technologically limited, and isolated. Each stone, terrace, and alignment stands as a testament to human ingenuity, urging us to look beyond the accepted narrative and to confront the possibility that civilization, in forms more advanced than we have imagined, existed long before we ever recorded its story. Across deserts, mountains, and river valleys, countless ancient structures have long stood as silent witnesses to human ingenuity, yet many of them contain elements so advanced that they challenge the conventional understanding of early civilizations. These megalithic wonders are not merely impressive because of their size, but because of the precision, planning, and technical sophistication they reveal, characteristics that often seem impossible given the assumed technological limitations of their time. Scholars have studied these sites for centuries, yet each new discovery adds layers of complexity, forcing historians, engineers, and archaeologists to confront uncomfortable questions about human capability, lost knowledge, and the possibility of advanced societies that existed far earlier than mainstream history admits. One of the most striking features of these ancient constructions is the sheer scale of the materials involved. Massive stone blocks, some weighing tens or even hundreds of tons, were quarried, transported over considerable distances, and placed with a precision that modern engineers still find difficult to replicate. The methods by which such feats were accomplished remain the subject of intense debate. Traditional explanations, which rely on ropes, levers, ramps, and large labor forces, often fail to account for the intricate fit of the stones, the smoothness of their surfaces, and the precision with which massive blocks align with each other across vast structures. The stones are not simply stacked, they interlock, forming joints that are impervious to erosion and seismic activity. This degree of craftsmanship implies knowledge of geometry, structural engineering, and material science that conventional historical narratives do not recognize. Puma Punku in Bolivia provides one of the clearest examples of this technological enigma. The site contains massive stone platforms and terraces, with blocks cut and shaped with extraordinary accuracy. Some of these stones bear complex geometrical patterns, perfectly straight edges, and precise holes that are aligned with mathematical regularity. The tools required to achieve such perfection are assumed to be beyond the reach of the civilizations credited with the construction of the site. The question of how these stones were cut, shaped, and transported across challenging terrain remains unanswered, highlighting the gap between observable evidence and conventional explanations. The level of planning required for such a project suggests that the builders possessed knowledge of engineering and logistics far beyond what historians have traditionally acknowledged. In Egypt, the Great Pyramid of Giza presents a similarly perplexing case. Scholars have long marveled at the precision with which the pyramid was constructed, noting that its sides are aligned almost perfectly with the cardinal points and that the internal chambers and passageways exhibit sophisticated architectural understanding. The size and weight of the limestone and granite blocks, combined with the mathematical precision of the layout, pose enormous challenges to conventional theories of construction. Even with modern technology, replicating the exact alignment and structural integrity of the pyramid would be a formidable task. The implication is that the ancient Egyptians had access to advanced engineering techniques, detailed planning, and perhaps knowledge of mathematics and astronomy that remains poorly understood. In addition to scale and precision, alignment and orientation are recurring elements that point to a sophisticated understanding of the natural world. Across continents, ancient builders appear to have aligned structures with celestial bodies, solstices, equinoxes, and other astronomical events. This pattern suggests a purpose beyond mere functionality, indicating that these structures were designed with both scientific and ceremonial considerations in mind. The builders had to observe the heavens carefully, understand cycles of the sun and stars, and integrate that knowledge into large-scale construction projects. Such alignment implies a sophisticated combination of observational astronomy, engineering, and cultural intent, a level of integration that challenges the assumption that early societies were limited to basic survival and ritual practices. Moreover, the recurrence of similar construction techniques across distant regions raises the possibility of a shared knowledge or tradition that predates the civilizations recorded in history. From the Andes to Egypt, from India to China, ancient sites display remarkably consistent methods: precisely cut stones, interlocking joints, leveled foundations, and careful orientation. Whether this consistency results from parallel development under similar environmental conditions or from the transmission of advanced knowledge across time and space, it underscores the inadequacy of conventional historical timelines. The possibility of a precursor civilization, global in influence or at least highly advanced locally, cannot be dismissed when confronted with such repeated architectural sophistication. The logistical challenges alone are staggering. Transporting massive stones across rivers, mountains, or deserts requires not just manpower but knowledge of physics, friction, leverage, and the structural limits of materials. Coordinating labor forces over decades or even centuries, as some projects likely required, demands social organization, administrative capacity, and intergenerational planning. These are attributes not typically assigned to societies considered primitive by mainstream historical standards. Yet the evidence demonstrates that the builders of these structures possessed exactly these capabilities. Each site becomes a testament not just to technical skill but to the social complexity and organizational ability necessary to realize such monumental projects. Beyond the technical and logistical marvels, there is also a symbolic and cultural dimension. Many of these structures served religious, ceremonial, or astronomical purposes, suggesting that they were central to the spiritual and societal life of their communities. Alignments with celestial bodies, incorporation of sacred geometries, and integration into natural landscapes reflect an understanding of the interplay between the physical and spiritual worlds. The scale and permanence of these constructions indicate that their creators sought to leave a legacy, embedding knowledge and cultural significance into stone that would endure far beyond their lifetimes. This dual focus, practical engineering and symbolic meaning, reveals a sophistication of thought that challenges the notion of early societies as solely functional or survival-focused. Another perplexing aspect is the durability and endurance of these structures. Many have withstood millennia of earthquakes, floods, and other natural disasters. The precise cutting, interlocking construction, and attention to structural stability suggest that the builders had an advanced understanding of physics and materials, whether through empirical observation or lost technologies. The endurance of these structures not only preserves the knowledge of ancient craftsmanship but also serves as a direct challenge to assumptions about the progression of human capability. If such expertise existed thousands of years ago, it implies that knowledge may have been lost, suppressed, or forgotten, raising profound questions about the gaps in our historical understanding. The emotional and psychological impact of confronting these megastructures is equally significant. Standing before a massive, perfectly aligned stone, one cannot help but feel awe at the ingenuity required to create it. At the same time, there is a sense of unease, a realization that human history may be far more complex than the stories we have been taught. The discrepancy between observable evidence and accepted narratives forces a confrontation with uncomfortable possibilities, that civilizations capable of extraordinary achievements may have existed long before recorded history, that knowledge may have been lost, and that our understanding of human capability is incomplete. Ultimately, these megastructures compel a re-evaluation of the human past. They demonstrate that early societies possessed technical expertise, organizational skills, and cultural sophistication far beyond what conventional timelines suggest. The scale, precision, and distribution of these constructions indicate that civilization may have existed in advanced forms long before the historical record begins. Each site stands as a testament to human ingenuity, challenging us to reconsider assumptions about progress, intelligence, and the continuity of knowledge. As we uncover and study these ancient marvels, we are reminded that history is not linear, that the past is far richer and more mysterious than textbooks allow, and that the story of humanity may include achievements we are only beginning to understand. Across the highlands, deserts, and jungles of the ancient world, one of the most compelling enigmas lies not merely in the monumental structures themselves, but in the precision and sophistication of the tools and techniques that must have been employed to construct them. For centuries, archaeologists have struggled to reconcile the scale and accuracy of ancient megalithic works with the technological capabilities traditionally attributed to the civilizations responsible. Massive stone blocks, sometimes exceeding 100 tons, are cut, shaped, and fitted with a degree of precision that challenges the limits of even modern engineering. Yet, little to no evidence of the necessary tools or methods has been discovered, leaving researchers to speculate, theorize, and, at times, confront the uncomfortable notion that our understanding of early human technology may be deeply incomplete. Consider, for example, the intricate stonework at Pumapunku in Bolivia. Here, enormous sandstone and andesite blocks were cut into perfectly straight edges, drilled with cylindrical holes, and fitted together so tightly that even a thin blade cannot be inserted between the stones. The shapes of the blocks, L-shaped, T-shaped, and with precise right angles, indicate an understanding of geometry and interlocking construction far beyond what copper or bronze tools could achieve. Archaeologists have attempted to replicate these cuts with primitive instruments, only to find that the process is labor-intensive, imprecise, and often incapable of producing the required results. The methods by which these stones were quarried, transported, and assembled remain a puzzle, suggesting either lost technologies or unknown techniques that allowed ancient builders to achieve feats still admired today. In Egypt, the Great Pyramid of Giza presents another conundrum. The limestone and granite blocks that form the pyramid's core and casing are quarried with extraordinary care, transported over long distances, and assembled with staggering precision. The internal chambers, passageways, and ventilation shafts demonstrate not only engineering ingenuity but also an understanding of stress distribution and structural integrity that modern engineers can recognize as sophisticated even by today's standards. While traditional explanations invoke large labor forces and simple tools like copper chisels, ramps, and sledges, these accounts fail to account fully for the level of precision and the speed at which such massive stones could have been cut and moved. The absence of comprehensive records detailing construction methods adds to the mystery, leaving a gap between what is physically observable and what conventional archaeology can explain. Similar mysteries are found across Asia. In India, the monolithic carvings at Ellora and other rock-cut temples required both meticulous planning and an intimate knowledge of stone properties. Artisans were able to remove massive volumes of rock to create freestanding structures with complex interiors, precise alignments, and delicate carvings, all executed without the benefit of modern machinery. In China, ancient stone terraces and temples display exacting geometric layouts and interlocking construction methods, often aligned with cardinal points or celestial events. These examples suggest that a sophisticated understanding of materials, geometry, and long-term planning existed independently across widely separated cultures, raising questions about the origins and transmission of this knowledge. The tools and techniques necessary to achieve such feats remain a subject of speculation. Traditional archaeology posits that simple copper or bronze chisels, stone hammers, and levers were used, but experimental archaeology has shown these methods to be extremely slow and often incapable of producing the observed precision. Some researchers have proposed advanced techniques such as stone softening methods, which could have allowed harder stones to be carved with relative ease, though evidence for such methods remains scarce. Others suggest that the builders possessed knowledge of geometry, angles, and measurement systems that allowed them to plan and execute projects with extraordinary accuracy, compensating for the limitations of their physical tools. In either case, the evidence points to a level of sophistication that exceeds what is commonly attributed to early civilizations. Another striking aspect of these ancient projects is the apparent understanding of physics and structural engineering. At sites like Machu Picchu and Ollantaytambo, massive stone terraces are arranged to withstand seismic activity and heavy rainfall, indicating that the builders had carefully studied the behavior of materials under stress. Foundations are leveled with remarkable precision, walls are interlocked to prevent collapse, and drainage systems are integrated seamlessly into the design. These structural decisions suggest empirical knowledge of load distribution, friction, and stability, principles that modern engineers formalize today but that ancient builders seemingly applied instinctively or through lost empirical methods. The level of planning required implies not only technical skill but also the social organization to coordinate large-scale labor and sustain projects over many years or even decades. The astronomical alignments observed in these sites further complicate our understanding of ancient technology. Many megalithic constructions are oriented with the sun, moon, and stars in mind, aligning with solstices, equinoxes, or specific stellar configurations. Achieving such alignment requires careful observation, calculation, and precise execution during construction. The correlation between astronomical knowledge and architectural execution suggests that ancient builders combined observational science with engineering, integrating technical and ceremonial objectives into a single project. This combination of scientific understanding, technical skill, and cultural intent underscores the complexity of the societies responsible and challenges the notion that they were technologically simplistic. The global distribution of these advanced constructions reinforces the puzzle. From South America to Egypt, from the Indian subcontinent to East Asia, structures with similar precision, alignment, and material sophistication appear across widely separated civilizations. Whether this represents independent innovation, shared knowledge through lost networks, or remnants of a precursor civilization, the pattern is clear: advanced building techniques were not confined to a single culture or geographic area. The recurrence of these features across continents and millennia implies that human ingenuity has deep roots, often predating the civilizations traditionally credited with technological innovation. The absence of concrete evidence regarding the tools used has fueled speculation about lost technologies. Could ancient civilizations have developed methods for cutting, transporting, and fitting massive stones that rival or exceed modern techniques? Were there tools, materials, or processes now forgotten, suppressed, or destroyed over time? These questions highlight the limits of conventional archaeology, which often assumes that linear technological progression is the default explanation. The physical evidence of ancient precision suggests that, at the very least, our understanding of early human capability is incomplete, and at worst, it is shaped by assumptions that obscure the possibility of highly advanced prehistoric knowledge. The impact of confronting these technological enigmas is both intellectual and emotional. Observing a perfectly fitted stone, a precisely aligned platform, or a massive monolith carved with geometric accuracy evokes awe at human ingenuity and ingenuity lost to time. At the same time, it provokes unease, the realization that societies existed with knowledge and skills far beyond what we are taught challenges our sense of historical continuity and progress. It forces the acknowledgement that the story of human civilization is not a simple, linear evolution from primitive to advanced but a complex tapestry of knowledge gained, lost, and sometimes rediscovered. Ultimately, the mystery of the tools and techniques used to create these ancient megastructures compels a re-evaluation of what we consider possible for early human societies. The precision, scale, and sophistication of these works suggest that knowledge may have been far more advanced than conventional history admits, that lost technologies or forgotten methods once existed, and that human capability in the ancient world was likely far more remarkable than we have been led to believe. These structures are not merely remnants of the past, they are evidence of intelligence, ingenuity, and achievement that challenge the very foundations of our understanding, urging us to reconsider the boundaries of history, technology, and the human story itself. Throughout human history, some of the most perplexing and awe-inspiring archaeological sites are those whose construction seems to defy not only the technological capabilities of their time but also the limits of human imagination. These enigmatic locations, scattered across the globe, are characterized by monumental precision, astronomical alignment, and an architectural sophistication that challenges our understanding of ancient civilizations. They are not merely impressive in scale or aesthetic design, they embody a level of planning, scientific knowledge, and logistical coordination that modern researchers continue to struggle to explain. The study of these sites forces a fundamental reconsideration of what early humans were capable of achieving and raises profound questions about lost knowledge, forgotten technologies, and civilizations whose achievements far exceed what conventional history recognizes. One of the most striking aspects of these advanced sites is the meticulous geometric precision evident in their construction. In the Andean highlands, for example, Puma Punku stands as a testament to the extraordinary skill of its builders. Massive sandstone and andesite blocks, some weighing more than 100 tons, are cut with straight edges, right angles, and precise holes, forming complex interlocking patterns that resist natural erosion and seismic activity. The craftsmanship evident in these blocks suggests not only mastery of stone-cutting techniques but also a sophisticated understanding of geometry and spatial planning. Experimental archaeology has repeatedly demonstrated the difficulty of reproducing such precision with the primitive tools traditionally attributed to the builders, highlighting the gap between observable evidence and conventional explanations. Equally compelling are the architectural marvels of ancient Egypt. The Great Pyramid of Giza exemplifies a level of engineering mastery that has perplexed scholars for centuries. Each of the millions of limestone and granite blocks is precisely aligned to form a perfect square, with sides oriented almost exactly to the cardinal points. Internal chambers and passageways exhibit advanced understanding of weight distribution and structural integrity, while ventilation shafts and alignment with celestial phenomena suggest a deliberate integration of scientific observation into architectural design. Despite centuries of study, the methods used to quarry, transport, and assemble these massive stones remain a subject of debate. Conventional theories involving ramps, sledges, and large labor forces fail to fully account for the precision and efficiency achieved, leaving room for speculation about lost technologies or unknown techniques. In Asia, the rock-cut temples of India and stone terraces of China provide additional evidence of extraordinary ancient skill. At Ellora, for example, artisans carved massive monolithic structures directly from bedrock, creating freestanding temples, intricate interiors, and elaborate facades with perfect symmetry. The scale and precision of the work, combined with the alignment of certain structures to cardinal directions and celestial events, indicate a sophisticated understanding of both materials and astronomical cycles. Similarly, Chinese stone terraces and ceremonial complexes exhibit remarkable geometric accuracy and interlocking construction methods. Across these distant regions, a pattern emerges: advanced engineering principles, precise stonework, and careful alignment with the natural and celestial environment appear repeatedly, suggesting either the transmission of knowledge across vast distances or the existence of a lost tradition of sophisticated construction techniques. The technological challenges of creating these ancient megastructures are staggering. Moving massive stones across uneven terrain, lifting them into precise positions, and cutting them to exact dimensions would require not only immense labor but also a deep understanding of physics, material science, and mechanical advantage. The precision of the work implies tools or methods capable of producing highly accurate measurements, yet archaeological evidence for such tools is scarce or non-existent. Some scholars have proposed techniques such as advanced lever systems, stone softening methods, or the use of water and sand to facilitate shaping and transport, but definitive evidence remains elusive. The absence of records explaining construction methods only deepens the mystery, highlighting the extraordinary achievement these structures represent. Beyond engineering, many of these sites demonstrate a sophisticated understanding of astronomy. Structures across the globe appear aligned with the sun, moon, and stars, often marking solstices, equinoxes, or other significant celestial events. This indicates careful observation over long periods, precise calculation, and the integration of astronomical knowledge into architectural planning. The combination of practical construction, ceremonial significance, and celestial alignment suggests that these societies were capable not only of physical feats but also of abstract thinking and the application of complex scientific principles. It reflects a worldview in which architecture, astronomy, and cultural or religious practice were deeply interconnected. The recurrence of similar construction techniques across geographically distant cultures is particularly intriguing. From South America to Egypt, from India to China, ancient builders employed comparable methods: interlocking stones, precise leveling, alignment with celestial events, and attention to structural stability. Whether this represents independent parallel development or knowledge transferred across cultures remains unknown, but the similarities are striking. They hint at a continuity of understanding or perhaps a lost civilization whose knowledge influenced multiple regions long before the rise of recorded history. These patterns challenge the conventional narrative of human progress as strictly linear, suggesting instead periods of advanced achievement that may have been lost or forgotten over time. Social organization was also a critical factor in the creation of these megastructures. Coordinating large-scale labor, sustaining projects over decades, and maintaining precise standards would require complex administrative structures, specialized roles, and effective communication. The planning, logistics, and resource management involved indicate societies capable of organizing, educating, and motivating large populations over extended periods. This level of organization suggests that these civilizations were more complex than mainstream accounts typically allow, possessing social hierarchies, institutional knowledge, and cultural priorities that facilitated monumental construction. The cultural and symbolic significance of these structures further underscores their sophistication. Many appear to have been designed with ceremonial or spiritual purposes in mind, integrating sacred geometry, astronomical alignments, and symbolic motifs into functional architecture. The dual purpose, practical and ceremonial, demonstrates a nuanced understanding of the relationship between human activity, natural cycles, and the spiritual or cosmological worldview. These constructions were not merely functional, they were expressions of cultural identity, scientific observation, and philosophical understanding, embedding knowledge and meaning into stone that would endure for millennia. Durability is another remarkable feature of these ancient constructions. Many have withstood earthquakes, floods, erosion, and human activity, maintaining structural integrity over thousands of years. The combination of interlocking stones, leveled foundations, and careful site selection reflects an empirical understanding of stability and longevity. Such endurance suggests that ancient builders anticipated environmental challenges and designed their structures accordingly, applying practical engineering knowledge that modern construction often only replicates through advanced materials and technology. The mystery of these sites evokes profound emotional and intellectual responses. Observing massive stones cut with geometric precision, aligned with celestial bodies, and integrated into complex urban or ceremonial layouts inspires awe at human ingenuity. Simultaneously, it raises unsettling questions about lost knowledge and forgotten civilizations. If societies capable of such achievements existed thousands of years ago, then the conventional narrative of human history, of gradual, linear progression from primitive to advanced, must be reconsidered. The evidence suggests a far more intricate and nuanced story, with achievements and knowledge that may have been erased, lost, or deliberately forgotten over time. Ultimately, these advanced ancient sites compel a re-evaluation of the human past. They demonstrate that early civilizations were capable of extraordinary engineering, sophisticated astronomical observation, and complex social organization. The precision, scale, and global distribution of these constructions suggest that humanity's story is not a simple, linear progression but a tapestry of achievement, loss, and rediscovery. Each site serves as both a testament to human ingenuity and a challenge to conventional historical assumptions, urging us to reconsider the boundaries of what was possible for our ancestors and to explore the possibility that the history we know is only a fragment of a far deeper, richer, and more mysterious past. Across continents and millennia, the precision and sophistication of ancient construction have long confounded scholars, revealing a level of engineering, planning, and craftsmanship that seems almost impossibly advanced for the civilizations credited with these achievements. Among the most compelling evidence are the megalithic sites scattered from the Andean highlands to the deserts of Egypt, from the subcontinent of India to the islands of the Pacific. These sites are characterized not merely by size, but by the intricacy of design, the precision of stone cutting, and the integration of astronomical and environmental knowledge. They challenge conventional historical narratives, suggesting that societies capable of extraordinary technological and architectural feats existed far earlier than mainstream timelines admit, and that much of this knowledge has since been lost, obscured, or deliberately suppressed. Puma Punku in Bolivia provides one of the clearest examples of the enigma of ancient engineering. Here, massive stone blocks, some weighing over 100 tons, are cut with extraordinary precision, shaped into complex interlocking forms, and fitted together so seamlessly that even a razor blade cannot be inserted between them. The geometric accuracy of the cuts, including perfectly straight edges, right angles, and precise cylindrical holes, indicates knowledge of mathematics and engineering principles far beyond what was assumed possible for a civilization relying on copper tools. The logistics of transporting and assembling these stones, across uneven terrain, over long distances, and into intricate arrangements, imply a level of organizational capability, technical knowledge, and societal cohesion that challenges conventional interpretations of Andean culture during that period. In Egypt, the Great Pyramid of Giza exemplifies similar mysteries on a monumental scale. The alignment of the pyramid's base to the cardinal points, the precise leveling of its foundation, and the placement of millions of limestone and granite blocks demonstrate a mastery of geometry, astronomy, and construction techniques that continue to defy full explanation. Internal chambers and passageways reveal a sophisticated understanding of weight distribution and structural integrity, while ventilation shafts suggest an integration of engineering and celestial observation. Traditional explanations involving ramps, levers, and massive labor forces fail to account for the extraordinary precision achieved, leaving open the possibility that the builders had access to techniques, tools, or knowledge that has been lost to history. Asia offers equally remarkable examples. In India, the rock-cut temples and monolithic structures of Ellora and other sites required removing vast amounts of bedrock to create freestanding architectural wonders with intricate interiors, precise alignments, and aesthetic perfection. The process demanded not only extraordinary manual skill but also knowledge of geometry, material properties, and long-term planning. In China, ancient stone terraces, ceremonial platforms, and monumental buildings display similar characteristics, including interlocking construction, alignment to cardinal directions, and attention to structural stability. These examples suggest that the principles of advanced construction, applied independently or transmitted across cultures, were far more widespread than previously recognized, hinting at the existence of knowledge networks or forgotten civilizations with extraordinary technological prowess. The question of how these structures were built is central to the mystery. Experimental archaeology has attempted to replicate the methods traditionally proposed, including chisels, ropes, levers, sledges, and ramps, yet these approaches often fail to account for the precision, speed, and scale of ancient construction. Some researchers have proposed techniques such as softening stone with unknown processes, using advanced surveying tools, or leveraging water and friction to move massive blocks. While definitive evidence remains elusive, the need to explain the extraordinary accuracy, alignment, and structural integrity of these monuments has fueled debates over lost technologies and ancient ingenuity. The very existence of these structures suggests that conventional timelines of technological progress may be incomplete or oversimplified. Astronomical alignment is another common feature of these ancient works. Many structures, from South America to Egypt to Asia, are oriented according to solstices, equinoxes, or specific star positions. This requires long-term observation, mathematical calculation, and the precise integration of celestial knowledge into architectural planning. Such sophistication implies that these societies combine practical engineering with scientific inquiry, understanding cycles of the sun, moon, and stars in ways that informed both functional construction and ceremonial or cultural practices. The deliberate orientation of buildings, terraces, and monoliths reveals a worldview in which the cosmos, human activity, and architecture were deeply interconnected. The recurrence of similar construction methods across distant regions is especially intriguing. Interlocking stones, precise leveling, geometric cutting, and astronomical alignment appear repeatedly, suggesting either independent innovation under similar environmental or social pressures or the transmission of knowledge across continents in a manner not recorded in conventional history. Some researchers propose the existence of a lost global civilization or advanced knowledge network whose influence spread widely before being fragmented by cataclysm, migration, or cultural change. Regardless of the explanation, the parallels point to a continuity of understanding and technical capability that mainstream history has yet to fully acknowledge. Social organization played a crucial role in enabling these monumental projects. Coordinating labor, sustaining large-scale construction over decades, and ensuring precise standards required complex governance structures, specialized roles, and efficient communication. These were societies capable of mobilizing significant resources, maintaining skilled workforces, and managing multi-generational projects. The scale and precision of their work indicate not only technical skill but also sophisticated administrative and social frameworks, challenging assumptions about the primitiveness of early civilizations. Durability and endurance are also remarkable. Many ancient structures have survived millennia of natural disasters, including earthquakes, floods, and erosion, while retaining their structural integrity. This suggests an empirical understanding of engineering principles such as weight distribution, interlocking construction, and foundation stabilization. Builders likely studied materials and environmental forces to ensure longevity, anticipating challenges that modern engineers would approach with advanced technology. The enduring nature of these constructions is a testament to the intelligence and foresight of their creators. Cultural and symbolic significance further adds depth to these sites. Many constructions incorporate sacred geometry, alignments with celestial events, and symbolic motifs, reflecting a synthesis of practical engineering and spiritual or ceremonial purpose. They are not merely functional, they express cultural identity, philosophical understanding, and a relationship between humanity and the cosmos. By integrating scientific knowledge with ritual practice, ancient builders demonstrated a holistic understanding of their world, embedding meaning into structures that would endure for millennia. Emotionally, these sites provoke awe, wonder, and unease. Observing a perfectly cut stone, a precisely aligned platform, or an interlocking monument challenges our sense of human capability and history. The accomplishments represented demand admiration, yet they also unsettle, suggesting the existence of knowledge and technology lost to time. The contrast between what is physically evident and what conventional history records raises profound questions about the trajectory of human development, lost civilizations, and forgotten achievements. Ultimately, these advanced ancient sites compel a re-evaluation of the human past. They demonstrate that early societies were capable of extraordinary engineering, sophisticated astronomical observation, and complex social organization. Their precision, scale, and distribution suggest that human civilization may have achieved technological and architectural heights far earlier than traditionally recognized. Each site serves as a testament to ingenuity, challenging assumptions about the limitations of early humans and encouraging a reconsideration of history as a narrative of progress, loss, and rediscovery. These constructions remind us that the story of humanity is far deeper, more intricate, and far more mysterious than conventional accounts allow, urging ongoing exploration, curiosity, and openness to the extraordinary possibilities of the ancient world. Across the ancient world, the phenomenon of advanced engineering and monumental construction extends far beyond the visible structures we have come to admire today. Beneath the surface of deserts, forests, and even the sea, hidden layers of ancient architecture reveal a level of sophistication, planning, and technical knowledge that defies the assumptions of conventional history. These hidden and often buried megastructures challenge our understanding of early civilizations, raising profound questions about the origins of human ingenuity, the potential for lost knowledge, and the civilizations that may have existed long before those recorded in historical texts. The study of these sites forces us to reconsider the nature of human development, technological progress, and the social structures required to achieve feats of such scale and precision. One of the most striking aspects of these hidden structures is the precision with which they were built, despite the limitations of the tools and technologies traditionally attributed to their creators. In South America, for instance, the massive stone platforms and interlocking blocks of Puma Punku exhibit cuts so precise that modern tools struggle to replicate them. Holes are drilled with exact circularity, edges are perfectly straight, and complex geometrical patterns interconnect massive stones weighing tens to hundreds of tons. The alignment of these blocks, combined with the sophisticated cutting techniques, indicates not only technical skill but also careful planning and an understanding of structural mechanics. How a civilization with presumed primitive tools could achieve such feats remains one of the most perplexing questions in archaeology. Beneath the deserts of Egypt, similar mysteries are evident in the construction of the pyramids and surrounding complexes. The Great Pyramid of Giza, for example, stands as a testament to extraordinary planning, engineering, and knowledge of mathematics and astronomy. Its base is perfectly aligned with the cardinal points, and the internal chambers are designed to distribute weight and resist seismic forces. Scholars have long debated the methods used to transport and assemble the massive limestone and granite blocks, with conventional explanations such as ramps and levers falling short of fully accounting for the speed, precision, and scale of construction. The architectural sophistication suggests that the builders possessed a deep understanding of physics, geometry, and structural integrity, challenging the assumption that such knowledge was beyond the reach of ancient societies. In Asia, monolithic rock-cut temples in India, like those at Ellora and Kailasa, offer additional examples of advanced engineering. Artisans carved entire structures directly from solid bedrock, creating freestanding temples with intricate interiors, precise alignments, and detailed ornamental work. The scale of these constructions required not only immense manual labor but also a mastery of geometry, measurement, and material properties. Similarly, ancient stone terraces and ceremonial platforms in China display precise leveling, interlocking stone techniques, and alignments with celestial bodies. The consistency of such sophisticated construction across diverse regions raises questions about the transfer of knowledge, the existence of lost civilizations, or a shared understanding of architecture and astronomy that predates recorded history. The construction methods of these ancient societies remain enigmatic. While experimental archaeology has attempted to replicate the techniques using tools available at the time, such as stone hammers, copper chisels, levers, and sledges, these methods often fail to achieve the precision and efficiency observed in the original structures. Some researchers speculate that ancient builders may have employed unknown methods, such as softening stone through chemical or mechanical means, or using water and friction to facilitate the movement of massive blocks. Others suggest advanced surveying techniques and mathematical systems enabled accurate measurements and alignments. The absence of direct evidence for these methods adds to the mystery, but the physical results themselves speak to a knowledge that appears far more advanced than mainstream narratives acknowledge. Astronomical alignment is a recurring theme in these ancient constructions. Many of the sites, from South America to Egypt to Asia, are oriented with the sun, moon, or stars, marking solstices, equinoxes, or other significant celestial events. Such alignment requires careful observation over long periods, precise calculation, and meticulous execution during construction. The integration of astronomical knowledge into architecture suggests that these civilizations possessed a sophisticated understanding of the natural world and applied it practically, creating structures that served both functional and ceremonial purposes. The fusion of technical precision and cosmological symbolism demonstrates a level of abstract thinking that challenges conventional ideas about prehistoric cognition and scientific understanding. The social organization necessary to achieve these feats is equally remarkable. Coordinating large labor forces, managing resources, and maintaining consistent quality over decades or centuries requires advanced administrative systems and hierarchical social structures. The scale and complexity of these projects suggest societies capable of sustaining long-term planning, specialized training, and intergenerational knowledge transfer. These characteristics indicate that the builders were not only technically skilled but also socially sophisticated, with the organizational capacity to support monumental construction and maintain cultural continuity. The existence of such organized and technologically adept societies calls into question the linear progression model of human development that portrays early civilizations as simple or primitive. Durability and longevity are also defining features of these ancient structures. Many have survived millennia of natural disasters, including earthquakes, floods, and erosion, while maintaining structural integrity and functional design. Builders appear to have understood the behavior of materials under stress, implementing interlocking construction, precise leveling, and foundation stabilization to ensure resilience. This empirical knowledge of engineering principles underscores the advanced understanding possessed by ancient civilizations and challenges the notion that technological sophistication is a modern phenomenon. The ability to construct structures that endure thousands of years speaks to both technical mastery and foresight. Cultural and ceremonial significance is deeply intertwined with practical engineering in these sites. Many constructions incorporate sacred geometry, alignments with celestial events, and symbolic motifs, reflecting a holistic worldview that integrates science, art, and spirituality. These structures were not merely functional, they conveyed cultural meaning, reinforced social hierarchies, and embodied cosmological principles. The deliberate combination of practical and symbolic design indicates that ancient builders valued both utility and meaning, creating enduring monuments that communicated knowledge and cultural identity across generations. This integration of purpose demonstrates a depth of thought and sophistication that challenges the assumption that early civilizations focused solely on survival. The emotional impact of confronting these hidden ancient structures is profound. Observing perfectly cut stones, interlocking blocks, and aligned platforms inspires awe at the ingenuity of human beings who lived thousands of years ago. At the same time, it evokes a sense of wonder and unease, as the existence of such advanced achievements suggests the presence of knowledge, techniques, and societal organization that have been lost to history. The realization that civilizations capable of extraordinary feats may have preceded those recorded in historical texts forces a re-evaluation of human progress, intelligence, and cultural development. These structures are both a testament to human potential and a challenge to the completeness of our historical understanding. The implications of these hidden constructions are far-reaching. They suggest that ancient civilizations may have achieved technological and architectural feats long before mainstream history credits them, that knowledge may have been lost through cataclysm, neglect, or deliberate suppression, and that the trajectory of human development is far more complex than linear models suggest. The hidden structures challenge historians, archaeologists, and engineers to reconsider assumptions about what early humans could achieve, prompting exploration into alternative explanations, advanced techniques, and the potential existence of precursor civilizations whose achievements shaped the foundations of human history. They call into question the narrative of human advancement as a gradual accumulation of knowledge, hinting at periods of extraordinary sophistication now obscured by time. Ultimately, the study of these hidden ancient megastructures compels a fundamental re-evaluation of humanity's past. They demonstrate that early civilizations were capable of extraordinary engineering, complex social organization, astronomical observation, and cultural expression. Their scale, precision, and global distribution suggest that human ingenuity existed at a high level far earlier than commonly acknowledged. Each site stands as both evidence of what humanity has achieved and a challenge to what we think we know. They remind us that history is a far richer, deeper, and more mysterious tapestry than conventional accounts reveal, urging us to explore, question, and remain open to the extraordinary possibilities of our ancient world. Across the ancient landscapes of the world, there exists a class of structures whose scale, precision, and alignment with natural and celestial phenomena continue to astonish modern researchers. These constructions, often buried beneath layers of earth, sand, or even water, challenge conventional assumptions about the technological and intellectual capabilities of early human societies. Unlike ordinary settlements or ritual sites, these megastructures reveal an extraordinary level of planning, material mastery, and understanding of geometry and astronomy. They force us to confront the possibility that civilizations with knowledge and engineering skills far exceeding what has traditionally been acknowledged existed long before the civilizations recorded in mainstream history. In South America, the archaeological site of Tiwanaku and its adjoining complex, Puma Punku, offers striking evidence of advanced prehistoric engineering. Here, massive stone blocks, some weighing over 100 tons, are precisely cut and interlocked with millimeter accuracy. The geometric shapes of the stones, including L-shaped, T-shaped, and right-angled configurations, suggest sophisticated knowledge of mathematics and construction. What is particularly remarkable is not just the size or weight of these blocks but the precision with which they fit together, leaving no gaps even after thousands of years. The stones display perfectly straight edges, uniform surfaces, and intricate drilled holes, all of which imply tools, techniques, or knowledge that remain unidentified by conventional archaeology. Transporting these stones across rugged terrain and arranging them with such precision would have required immense logistical planning and a high degree of social organization, raising questions about the sophistication and coordination of the society that built them. Similarly, in Egypt, the pyramids and surrounding complexes continue to evoke awe and mystery. The Great Pyramid of Giza, constructed from millions of limestone and granite blocks, demonstrates remarkable precision in alignment, leveling, and structural integrity. Its base is oriented almost perfectly to the cardinal points, internal chambers are designed to distribute weight effectively, and certain passageways and shafts align with key celestial bodies. Conventional explanations suggest the use of ramps, levers, and vast labor forces. However, these theories struggle to account for the accuracy, efficiency, and methods by which massive stones were quarried, transported, and positioned with such uniformity. The pyramids exemplify the integration of practical engineering with knowledge of astronomy and geometry, reflecting a civilization capable of applying sophisticated principles that modern researchers still find difficult to fully replicate. In Asia, particularly in India and China, monolithic rock-cut temples, terraces, and ceremonial structures further attest to advanced ancient engineering. At Ellora, artisans carved entire temples directly from solid rock, creating freestanding structures with elaborate interiors, precise proportions, and intricate decorative elements. Such work required an intimate understanding of stone properties, geometry, and load-bearing principles, as well as the coordination of labor over long periods. Chinese stone terraces and ceremonial platforms exhibit similar engineering mastery, including interlocking stone techniques, precise leveling, and careful alignment with cardinal points and astronomical phenomena. The recurrence of these features across geographically distant regions suggests either the existence of a lost global knowledge system or independent societies achieving comparable technological and architectural sophistication, a prospect that continues to intrigue and challenge conventional history. One of the most puzzling aspects of these sites is the absence of direct evidence regarding the tools and techniques used to achieve such feats. Archaeological records provide little insight into the instruments or methods capable of cutting, shaping, and transporting massive stones with the precision observed. Experimental archaeology has attempted to replicate these processes using primitive tools such as copper chisels, stone hammers, and basic levers, but results often fall far short of matching the original craftsmanship. Some researchers speculate that ancient builders may have employed advanced, now lost techniques, possibly including methods to soften or manipulate stone, specialized surveying systems, or highly refined leverage and transport methods. Whatever the approach, the outcome demonstrates a level of technical mastery that defies conventional timelines of human development. Astronomical alignment plays a central role in understanding these structures. Across continents, ancient builders appear to have intentionally oriented their constructions according to celestial events such as solstices, equinoxes, and the rising or setting of significant stars. Achieving such alignment requires sustained observation, careful measurement, and precise execution during construction. The integration of astronomical knowledge with architectural planning suggests that these civilizations were not only technically proficient but also capable of abstract thought and complex scientific observation. Structures aligned with celestial events may have served ritualistic, ceremonial, or calendrical purposes, reflecting a deep interconnection between human activity, spirituality, and the cosmos. The organization and social structure necessary to build such monuments are equally remarkable. Coordinating large labor forces, ensuring consistent standards of workmanship, and sustaining multi-decade or multi-generational projects implies the existence of advanced administrative systems and hierarchical social structures. These societies required mechanisms for resource management, communication, and long-term planning, demonstrating levels of complexity often underestimated in conventional historical narratives. The ability to mobilize human and material resources on such a scale reflects not only technical ingenuity but also cultural and political sophistication, suggesting that these civilizations were far more capable than traditionally assumed. Durability and resilience are additional hallmarks of these constructions. Many have survived thousands of years of earthquakes, floods, and erosion while maintaining structural integrity. Builders appear to have understood the principles of interlocking construction, weight distribution, and foundation stability, ensuring longevity in structures that were intended to endure generations. The enduring nature of these monuments serves as both a testament to the intelligence of their creators and a challenge to modern assumptions regarding ancient technological capability. The cultural and symbolic significance of these structures cannot be overstated. Many incorporate sacred geometry, alignments with astronomical events, and symbolic motifs reflecting religious, philosophical, or societal principles. The combination of functional engineering with symbolic meaning demonstrates a holistic approach to construction, in which technical, spiritual, and social considerations were integrated seamlessly. These structures were not merely utilitarian, they were expressions of worldview, identity, and knowledge designed to endure across time, communicating meaning and cultural values to future generations. Emotionally, encountering these ancient megastructures evokes a powerful sense of awe and wonder. Observers are confronted with the realization that human beings, thousands of years ago, were capable of achievements that continue to challenge our understanding today. The precision, scale, and integration of these constructions provoke admiration for human ingenuity, as well as a sense of mystery and unease, since so much knowledge appears to have been lost to history. These sites remind us that the achievements of the past may be far more advanced than we have been taught to believe, and that the trajectory of human development is far from linear or predictable. Ultimately, these hidden and often overlooked ancient megastructures compel a re-evaluation of our understanding of civilization. They reveal that early societies were capable of advanced engineering, sophisticated astronomical observation, and complex social organization, long before the civilizations traditionally credited with such achievements. The precision, durability, and global distribution of these sites suggest that humanity's technological and architectural history may be far richer, older, and more interconnected than conventional narratives acknowledge. Each structure stands as a testament to human ingenuity and creativity, challenging us to reconsider assumptions about the limits of our ancestors and urging us to explore the untold stories and lost knowledge of the ancient world. In doing so, we are reminded that history is not a simple chronological record but a tapestry of discoveries, achievements, and mysteries that continue to inspire awe and demand deeper inquiry. Across the globe, ancient civilizations have left behind monuments that not only reflect their cultural and religious values but also reveal an extraordinary mastery of engineering, architecture, and mathematics. These hidden and often overlooked megastructures challenge the conventional understanding of prehistoric societies, demonstrating a level of sophistication that suggests advanced knowledge and techniques now lost to time. Their existence raises profound questions about the capabilities of early humans, the possible existence of precursor civilizations, and the transmission of knowledge across generations and continents. Examining these sites provides an opportunity to rethink human history, uncovering evidence that civilizations once possessed skills and understanding far beyond what mainstream history credits them with. In South America, the site of Puma Punku and the larger Tiwanaku complex in Bolivia exemplifies this enigma. The construction features massive stone blocks, some weighing more than 100 tons, that are cut with incredible precision and interlocked in complex geometrical patterns. The edges of these stones are straight, right angles are exact, and drilled holes are perfectly cylindrical. No evidence has been discovered to suggest that conventional tools of the time, such as bronze chisels or stone hammers, could achieve this level of craftsmanship. Moreover, the transportation of these stones across uneven terrain, coupled with the logistical coordination required to assemble them in precise arrangements, indicates a society capable of extraordinary planning and organization. The site raises difficult questions. How were these stones shaped with such accuracy? How were they transported and assembled? And why was such effort expended to create structures that endure millennia? In Egypt, the pyramids and their surrounding complexes present a similarly puzzling scenario. The Great Pyramid of Giza, constructed from millions of limestone and granite blocks, demonstrates exceptional engineering skill, precise alignment with cardinal points, and remarkable leveling of its foundation. The internal chambers are meticulously designed to bear weight and distribute stress, while ventilation shafts appear to align with key celestial bodies. Traditional theories suggest the use of ramps, levers, and large labor forces to move and position the stones, yet these explanations struggle to account for the precise fit, smooth surfaces, and rapid construction timelines. The pyramids reflect a civilization that not only possessed advanced technical knowledge but also applied it in ways that integrated astronomy, mathematics, and structural engineering, indicating a sophisticated understanding of both the physical and natural world. In Asia, particularly India and China, monolithic rock-cut temples, terraces, and ceremonial platforms showcase comparable achievements. At Ellora, massive rock formations were carved into freestanding temples with precise interiors, decorative carvings, and structural stability. The labor required to execute such work suggests the presence of highly skilled artisans, advanced planning, and methods for measuring and shaping stone that remain poorly understood. In China, ceremonial platforms and monumental stone terraces display interlocking construction techniques, careful leveling, and alignment with cardinal directions and celestial events. These sites, spread across continents, reveal striking similarities in technique and design, raising questions about the potential transfer of knowledge between civilizations or the existence of parallel developments that reached comparable levels of sophistication independently. The technology required to create these megastructures remains a topic of intense debate. Experimental archaeology has attempted to replicate ancient methods using copper chisels, stone hammers, and basic levers, yet these trials often fail to achieve the precision and scale evident in the original works. Some researchers speculate about advanced, lost technologies, possibly including methods for softening stone, using water or friction to move massive blocks, or employing highly refined surveying and measurement systems. While definitive proof of such methods remains elusive, the outcome of the original constructions demands acknowledgement of knowledge and skills that surpass conventional assumptions about prehistoric civilizations. The mere existence of these structures indicates that human capability in the ancient world was far more remarkable than previously recognized. Astronomical alignment is a prominent feature in many of these constructions, highlighting the builders' sophisticated observational skills and understanding of celestial cycles. Structures in South America, Egypt, and Asia are often oriented to solstices, equinoxes, or the positions of significant stars. Achieving such alignments requires precise observation over long periods, mathematical calculation, and accurate execution during construction. The integration of astronomy into architecture demonstrates a fusion of science, engineering, and cultural significance. It suggests that these societies were not only capable of monumental construction but also understood the natural world at a level of sophistication that allowed them to link human activity with cosmic cycles, creating structures that were functional, symbolic, and spiritually meaningful. Social organization was critical to the creation of these monumental works. Coordinating labor forces, sustaining multi-decade or even multi-generational projects, and ensuring consistent workmanship across massive construction sites required complex administrative structures and effective communication. These societies needed hierarchical leadership, trained specialists, and resource management systems capable of supporting long-term projects. Such organizational sophistication is often underestimated in conventional historical accounts but is clearly implied by the scale, precision, and complexity of these constructions. The existence of these societal structures challenges the notion of early civilizations as technologically limited and socially simplistic. Durability and resilience further underscore the ingenuity of ancient builders. Many of these constructions have survived earthquakes, floods, and centuries of weathering while maintaining structural integrity. The use of interlocking stones, precise leveling, and carefully stabilized foundations demonstrates empirical knowledge of structural engineering principles that continue to inform modern construction. These enduring features indicate that the builders were not only concerned with immediate functionality but also with longevity, anticipating environmental challenges and ensuring that their creations would persist for generations. The combination of technical skill, foresight, and resilience suggests a level of intelligence and practical understanding that demands respect and reconsideration of ancient capabilities. The cultural and symbolic importance of these structures is equally profound. Many integrate sacred geometry, alignments with celestial events, and symbolic motifs that reflect religious, philosophical, or societal values. The fusion of functional engineering with spiritual and symbolic meaning illustrates a holistic worldview, in which technology, art, and culture were inseparably intertwined. These monuments were not merely utilitarian constructions, they were enduring expressions of identity, cosmology, and intellectual achievement, designed to communicate knowledge and values across generations. By embedding meaning into their architecture, ancient builders ensured that their legacy would survive not only physically but also culturally. Encountering these megastructures evokes a deep emotional response. Standing before massive, precisely cut stones, interlocking blocks, and perfectly aligned platforms instills a sense of awe at human ingenuity. Simultaneously, there is unease, as these achievements imply knowledge, tools, and organizational capabilities that seem lost to history. The realization that civilizations capable of such feats existed thousands of years ago forces a reassessment of what we know about human progress and intelligence. It challenges the narrative of linear technological development, suggesting instead that human history is punctuated by periods of extraordinary achievement that may have been lost or forgotten over time. Ultimately, these hidden ancient megastructures demand a re-evaluation of humanity's past. They demonstrate that early societies were capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. The precision, scale, and global distribution of these constructions suggest that human civilization may have reached technological and intellectual heights much earlier than mainstream history acknowledges. Each site stands as a testament to ingenuity, resilience, and the enduring human desire to create and understand, urging scholars and enthusiasts alike to explore, question, and expand the boundaries of what we know about the ancient world. These structures remind us that human history is not a simple, linear progression but a rich, complex tapestry filled with mystery, achievement, and knowledge that continues to challenge and inspire us. Across the landscapes of the ancient world, some of the most mysterious and awe-inspiring constructions are those that appear deliberately designed to defy time, nature, and conventional understanding. These hidden ancient megastructures are not just remarkable for their scale or visual impact, they embody an extraordinary mastery of engineering, geometry, and astronomy that continues to challenge modern researchers. From South America to Egypt, from the Indian subcontinent to East Asia, these structures reveal that civilizations long thought primitive possessed technical knowledge, organizational capacity, and scientific insight far beyond what mainstream history has typically acknowledged. Their construction raises profound questions about the origins of human ingenuity, the existence of lost technologies, and the possibility that civilizations of exceptional sophistication existed long before recorded history. In South America, the ruins of Puma Punku and the broader Tiwanaku complex in Bolivia provide some of the clearest examples of these technological enigmas. Massive stone blocks, some weighing over 100 tons, are cut with extraordinary precision and assembled in interlocking patterns that fit together seamlessly. The edges of these stones are straight, right angles are exact, and cylindrical holes are drilled with uniformity that modern machinery would find challenging to replicate. Transportation of these stones from distant quarries, across uneven terrain and up terraces, would have required careful planning, coordination, and a level of ingenuity that seems improbable given the technological assumptions about Andean societies. Experimental archaeology has attempted to reproduce such feats with simple tools like stone hammers and copper chisels, but these attempts consistently fall short, highlighting a gap between the observable evidence and conventional explanations. In Egypt, the pyramids and surrounding structures present a similarly compelling mystery. The Great Pyramid of Giza, constructed from millions of limestone and granite blocks, demonstrates extraordinary precision in alignment, leveling, and structural engineering. Its base is aligned almost perfectly to the cardinal points, internal chambers are carefully designed to distribute weight and resist collapse, and ventilation shafts appear to align with specific celestial bodies. Conventional theories suggest the use of ramps, levers, and large labor forces, but these explanations struggle to account fully for the speed, accuracy, and methodology required to assemble such massive stones with uniformity and geometric perfection. The pyramids exemplify a deliberate integration of architecture, mathematics, and astronomy, reflecting a civilization capable of sophisticated observation, planning, and technical execution. In Asia, monolithic rock-cut temples, terraces, and ceremonial complexes further attest to ancient ingenuity. At Ellora in India, entire temples were carved directly from solid bedrock, creating freestanding structures with precise interiors, decorative carvings, and structural stability. Executing such work would have required an intimate knowledge of stone properties, geometry, and load-bearing principles, alongside highly coordinated labor. Chinese ceremonial platforms and stone terraces reveal similar characteristics, including interlocking construction techniques, precise leveling, and alignment with celestial phenomena. The similarities across these distant regions suggest either the existence of a lost global knowledge system or independent cultures reaching comparable technological heights, challenging assumptions that such sophistication developed linearly or regionally. The technology necessary to produce these megastructures remains elusive. Archaeological records offer little evidence of the tools or methods used to cut, shape, and transport massive stones with such precision. While experimental archaeology has attempted to replicate ancient techniques with simple instruments like chisels, hammers, and levers, these methods often fall short of achieving the results observed at the sites themselves. Some researchers propose that ancient builders may have employed advanced, now-lost technologies, such as stone softening methods, highly refined surveying and measurement techniques, or methods for moving enormous blocks with minimal friction. Whatever the means, the resulting constructions display a level of skill and knowledge that challenges the conventional view of prehistoric technological capabilities. Astronomical alignment is another striking feature of these constructions. Across continents, ancient builders oriented structures according to the positions of the sun, moon, and stars, often marking solstices, equinoxes, or significant stellar events. Achieving such precision would have required careful observation over extended periods, accurate mathematical calculation, and meticulous execution. The integration of celestial knowledge into architectural design demonstrates that these civilizations were capable of abstract thinking, scientific observation, and the application of complex principles to functional and ceremonial construction. The careful orientation of monuments suggests not only technical skill but also a worldview in which architecture, society, and the cosmos were interconnected. The organizational and social structures required to undertake such monumental projects were equally remarkable. Coordinating labor, managing resources, and sustaining multi-generational construction efforts necessitated advanced administrative systems, hierarchical governance, and specialized training. These societies required a level of social complexity that facilitated long-term planning, consistent quality control, and the ability to mobilize human and material resources effectively. The scale, precision, and coordination evident in these projects indicate that these civilizations were not only technically adept but also culturally and politically sophisticated, challenging assumptions about the simplicity of early human societies. Durability and resilience are among the most impressive aspects of these ancient constructions. Many have endured millennia of environmental pressures, including earthquakes, floods, and erosion, while retaining structural integrity. Builders appear to have understood weight distribution, interlocking construction, and foundation stabilization, suggesting empirical knowledge of engineering principles that predate modern scientific methods. The ability to create structures capable of withstanding the forces of nature for thousands of years speaks to a level of foresight, intelligence, and technical expertise that demands recognition and re-evaluation of historical assumptions. The cultural and symbolic dimensions of these megastructures are equally profound. Many incorporate sacred geometry, astronomical alignments, and symbolic motifs, reflecting the fusion of practical engineering with philosophical, religious, or societal meaning. These constructions were not merely utilitarian, they communicated knowledge, reinforced social hierarchies, and embodied the cultural worldview of the civilizations that built them. By integrating science, art, and spirituality into their architecture, these societies created enduring monuments that conveyed meaning across generations, illustrating a holistic approach to knowledge and human achievement. Encountering these hidden and advanced structures evokes powerful emotional responses. The sight of massive, precisely cut stones, interlocking blocks, and meticulously aligned platforms inspires awe at the ingenuity of ancient builders. Simultaneously, it provokes a sense of unease, as the existence of such achievements implies knowledge, tools, and organizational capabilities that appear lost to history. The realization that civilizations capable of such feats existed thousands of years ago forces a re-evaluation of human potential and challenges the narrative of linear technological progression. These structures suggest that human history is punctuated by extraordinary periods of ingenuity, some of which may have been forgotten or erased over time. Ultimately, the hidden ancient megastructures compel a reassessment of humanity's past. They demonstrate that early civilizations were capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. Their scale, precision, and global distribution indicate that human ingenuity existed at a high level much earlier than mainstream history acknowledges. Each structure serves as both a testament to human achievement and a challenge to prevailing historical assumptions, reminding us that the story of humanity is far more complex, mysterious, and remarkable than conventional narratives suggest. These constructions encourage continued exploration, open-minded inquiry, and a recognition of the extraordinary capabilities of our ancient ancestors, revealing a human past that is both inspiring and humbling in its scope. Across the ancient landscapes of the world, certain constructions stand as enduring enigmas, provoking wonder, curiosity, and debate among scholars and enthusiasts alike. These megastructures, often hidden or partially buried, are remarkable not merely for their monumental scale but for the extraordinary precision, engineering mastery, and astronomical alignment they embody. They suggest civilizations that possess sophisticated knowledge far beyond what mainstream history typically attributes to their time periods, challenging conventional timelines of technological and intellectual development. From the Andes to Egypt, from the Indian subcontinent to China, these constructions provide compelling evidence that humanity's capabilities in architecture, mathematics, and astronomy were once far more advanced than widely acknowledged, raising profound questions about the origins, transmission, and possible loss of knowledge over millennia. In South America, the ruins of Tiwanaku and Puma Punku in Bolivia exemplify these mysteries. Massive stone blocks, some weighing more than 100 tons, are cut with extraordinary precision, fitted together in complex interlocking patterns, and shaped into geometrical forms that defy replication using the simple tools historically attributed to Andean societies. The blocks include perfect right angles, precise grooves, and cylindrical holes that suggest an understanding of geometry and engineering principles not thought to be available at the time. Transporting these massive stones across uneven terrain, lifting them into position, and assembling them with such precision would have required meticulous planning, specialized techniques, and a level of social coordination that challenges traditional assumptions about these cultures. Even today, the technology and methods necessary to reproduce such feats remain largely speculative, highlighting a gap between the observable evidence and our conventional understanding of prehistoric capabilities. Similarly, the pyramids of Egypt stand as monuments of unparalleled sophistication. The Great Pyramid of Giza, composed of millions of limestone and granite blocks, demonstrates remarkable precision in alignment, leveling, and structural integrity. Its base is almost perfectly oriented to the cardinal points, internal chambers are carefully designed to bear immense weight, and ventilation shafts appear to align with specific celestial bodies. Traditional explanations invoking ramps, levers, and large labor forces struggle to account fully for the speed, accuracy, and methods employed to achieve such perfection. The pyramids reveal a civilization capable of integrating engineering, geometry, and astronomical observation in ways that continue to awe modern engineers and historians alike, underscoring a level of technical understanding and planning that was previously thought impossible for the period. In Asia, the rock-cut temples and monolithic constructions of India, particularly at Ellora, highlight similar advanced capabilities. Entire temples were carved directly from solid rock, creating freestanding structures with intricate interiors, precise proportions, and detailed ornamental work. Executing such monumental projects would have required deep knowledge of stone properties, structural stability, and geometric measurement, as well as careful coordination of labor over extended periods. In China, ceremonial platforms, stone terraces, and urban constructions exhibit interlocking stone techniques, precise leveling, and alignment with cardinal directions and celestial events. The repetition of advanced construction methods across widely separated regions raises compelling questions about the transmission of knowledge, the potential influence of lost civilizations, or the possibility that human societies independently reached similar levels of technical sophistication in different contexts. The technological capabilities needed for such constructions remain a topic of intense study and debate. Archaeological evidence for the tools and techniques used is limited, and traditional methods involving simple chisels, stone hammers, and levers often fall short of explaining the precision and scale observed in the surviving structures. Some researchers propose lost technologies or advanced methods, such as techniques to soften stone for shaping, refined surveying instruments for alignment, or systems for moving massive blocks with minimal friction. While direct evidence for these techniques is scarce, the physical outcomes of the constructions themselves, precise geometrical forms, interlocking blocks, and astronomical alignment, suggest that ancient societies possessed knowledge and skills that remain largely unrecognized in conventional narratives of human history. Astronomical orientation is a striking and consistent feature of these ancient constructions. Many sites are deliberately aligned with the sun, moon, or stars, often corresponding to solstices, equinoxes, or other significant celestial events. Achieving such alignments requires long-term observation, precise measurement, and meticulous planning during construction. The integration of astronomy into architecture indicates that these civilizations combined practical engineering with scientific understanding, creating structures that were both functional and symbolic. This deliberate interweaving of technical and cosmological knowledge reflects a worldview in which human activity, ritual practice, and the cosmos were intimately connected, further emphasizing the sophistication of these ancient societies. Social organization was a crucial factor enabling these monumental achievements. Coordinating large labor forces, sustaining projects over decades or even generations, and maintaining consistent standards of construction required advanced administrative systems, hierarchical governance, and specialized expertise. These societies possessed the ability to mobilize resources efficiently, train skilled artisans, and plan long-term construction projects with remarkable precision. The scale and complexity of these undertakings suggest a level of societal sophistication often underestimated in conventional historical accounts, demonstrating that early civilizations were capable of organization, planning, and execution at levels comparable to much later periods. Durability and resilience are hallmarks of these ancient structures. Many have survived millennia of natural disasters, including earthquakes, floods, and erosion, while retaining their structural integrity. Builders clearly understood principles of interlocking construction, weight distribution, and foundation stability, ensuring that these structures could withstand environmental stresses over centuries. The enduring nature of these constructions provides tangible evidence of empirical knowledge of engineering principles and an understanding of materials that is both impressive and thought-provoking. The foresight required to construct monuments capable of surviving thousands of years is a testament to the intelligence, skill, and long-term vision of ancient civilizations. The cultural and symbolic dimensions of these megastructures are equally profound. Many incorporate sacred geometry, celestial alignments, and symbolic motifs that reflect religious, philosophical, or societal principles. The fusion of functional engineering with spiritual and cultural meaning illustrates a holistic approach to architecture, where practical, symbolic, and aesthetic considerations were inseparably intertwined. These constructions were intended not only to serve functional or ceremonial purposes but also to communicate knowledge, values, and cultural identity across generations. In this way, architecture became a medium for preserving and transmitting wisdom, reflecting a deep awareness of the relationship between human endeavor and the cosmos. Encountering these megastructures evokes both wonder and a sense of unease. The precision, scale, and ingenuity of the constructions inspire awe at human creativity and capability. Simultaneously, they provoke questions about lost knowledge, forgotten technologies, and civilizations whose achievements seem to have vanished from the historical record. The realization that societies thousands of years ago were capable of feats that continue to challenge modern understanding forces a re-evaluation of human history, suggesting that the conventional narrative of linear progress may be overly simplistic or incomplete. Ultimately, these hidden ancient megastructures compel a profound reconsideration of humanity's past. They demonstrate that early civilizations were capable of advanced engineering, astronomical observation, complex social organization, and cultural sophistication far beyond conventional expectations. Their scale, precision, and global distribution imply that human ingenuity existed at a high level much earlier than mainstream history typically acknowledges. Each site stands as a testament to human achievement and a challenge to prevailing assumptions, reminding us that the story of our ancestors is far more intricate, mysterious, and extraordinary than traditional narratives suggest. These structures encourage continued exploration, critical inquiry, and an appreciation for the vast, often overlooked capabilities of ancient human civilizations, offering a glimpse into a past that is both inspiring and humbling. Across the globe, ancient megastructures continue to defy conventional understanding, leaving historians, archaeologists, and engineers grappling with questions about the capabilities of early civilizations. These monuments are not only remarkable for their size and durability but also for the sophistication of their construction, the precision of their design, and the integration of astronomical and geometric knowledge. From the highlands of South America to the deserts of Egypt, and from the Indian subcontinent to East Asia, these hidden and often overlooked constructions suggest that early human societies possessed technical skills, organizational abilities, and scientific understanding far beyond what traditional narratives of history allow. The existence of these structures challenges assumptions about the linear progression of technological development and hints at lost knowledge or civilizations whose achievements have largely disappeared from the historical record. In South America, the Tiwanaku complex in Bolivia, including the enigmatic site of Puma Punku, exemplifies the advanced capabilities of ancient builders. Here, massive stone blocks, some exceeding 100 tons, are precisely cut and arranged in interlocking geometrical patterns. The stones feature perfectly straight edges, exact right angles, and cylindrical holes drilled with remarkable accuracy. Conventional explanations suggest that these stones were shaped using simple copper tools and moved with basic sledges or ramps, yet experimental archaeology has shown that achieving such precision with these methods is virtually impossible. Furthermore, the transportation of these enormous blocks over long distances and rugged terrain would have required a level of planning, coordination, and ingenuity that challenges existing assumptions about Andean civilizations. The site's construction demonstrates not only technical skill but also social organization capable of sustaining large-scale, multi-generational projects. Similarly, in Egypt, the Great Pyramid of Giza exemplifies ancient engineering at a monumental scale. Constructed from millions of limestone and granite blocks, the pyramid demonstrates extraordinary precision in alignment, leveling, and structural design. Its base is oriented almost perfectly to the cardinal points, and internal chambers are carefully engineered to distribute weight and withstand environmental stresses. Ventilation shafts are aligned with specific stars, suggesting integration of astronomical knowledge into the architectural plan. Traditional explanations involving ramps, levers, and labor armies are difficult to reconcile with the precision and efficiency observed. The pyramids reflect a civilization capable of blending mathematical understanding, structural engineering, and celestial observation in ways that continue to astonish modern researchers, challenging assumptions about the technological and cognitive abilities of early societies. In Asia, particularly in India and China, monolithic constructions, rock-cut temples, and ceremonial platforms further illustrate the advanced capabilities of ancient builders. At Ellora in India, artisans carved entire temples from solid rock, creating freestanding structures with intricate interiors, decorative motifs, and remarkable structural stability. The execution of such monumental work would have required detailed knowledge of stone properties, geometric planning, and load-bearing calculations, as well as the coordination of large, skilled workforces. In China, ceremonial stone platforms, terraces, and urban constructions display precise leveling, interlocking techniques, and alignment with cardinal directions and celestial events. The similarities in construction techniques across these distant regions raise intriguing questions about the transfer of knowledge, the existence of lost civilizations, or the potential for independent societies reaching comparable levels of technical sophistication. The technology and methods required for such construction remain a source of intense debate. While experimental archaeology has attempted to replicate ancient building techniques using rudimentary tools such as chisels, hammers, and levers, these methods often fail to achieve the same precision, scale, and efficiency as the original works. Some researchers have hypothesized the use of now-lost technologies, including methods for softening or manipulating stone, advanced surveying tools, or systems for moving massive blocks with minimal friction. The absence of direct evidence for these techniques only deepens the mystery, yet the results of the constructions themselves provide undeniable proof of extraordinary technical skill. These achievements compel a re-evaluation of what early civilizations were capable of, suggesting that much of our understanding of prehistoric technological advancement may be incomplete or overly conservative. Astronomical alignment is a common and significant feature of these ancient structures. Many sites are deliberately oriented according to the positions of the sun, moon, and stars, marking solstices, equinoxes, or other significant celestial events. Achieving such alignments requires long-term observation, precise calculation, and careful implementation during construction. The integration of celestial knowledge into architecture indicates that these societies possessed not only practical engineering skills but also the capacity for abstract thought and scientific observation. Aligning monumental constructions with cosmic events reveals a worldview in which human activity, architecture, and the cosmos were deeply interconnected, suggesting that these civilizations understood natural cycles in ways that informed both their practical and ceremonial endeavors. Social and organizational structures were crucial in enabling these monumental projects. Coordinating labor, sustaining construction over decades or even generations, and ensuring consistent quality demanded advanced administrative systems, hierarchical governance, and specialized expertise. These societies were capable of mobilizing large numbers of workers, managing complex logistics, and maintaining skilled artisan networks. The level of social sophistication required to plan, resource, and execute these constructions underscores that these civilizations were not only technologically adept but also culturally and politically advanced. Their achievements challenge conventional perceptions of early societies as primitive or unsophisticated, highlighting the intricate interplay between knowledge, organization, and capability. Durability and resilience are among the most remarkable characteristics of these constructions. Many ancient monuments have survived millennia of natural forces, including earthquakes, floods, and erosion, while retaining their structural integrity. Builders appear to have possessed empirical knowledge of engineering principles, including interlocking construction, weight distribution, and foundation stabilization, ensuring that their creations could endure centuries of environmental stress. The enduring nature of these structures reflects a sophisticated understanding of materials and their properties, as well as foresight in design and planning. Such longevity emphasizes that these civilizations approached construction not merely as a temporary endeavor but as a lasting testament to human ingenuity. The cultural and symbolic significance of these megastructures further enriches our understanding of their purpose. Many incorporate sacred geometry, astronomical alignment, and symbolic motifs, reflecting the integration of practical engineering with spiritual, philosophical, or societal meaning. These constructions were designed to communicate knowledge, reinforce social hierarchies, and embody cultural identity across generations. By merging functionality with symbolism, ancient builders created monuments that were both utilitarian and profoundly meaningful, serving as vessels for knowledge, religious observance, and cultural continuity. The depth of intentionality evident in these constructions underscores the sophisticated worldview and intellectual capacity of the societies that created them. Encountering these megastructures evokes a complex mixture of awe and uncertainty. Observing massive stones cut with precision, interlocking blocks, and perfectly aligned platforms inspires admiration for human creativity and ingenuity. At the same time, these achievements provoke questions about lost knowledge, forgotten technologies, and civilizations whose capabilities appear to have vanished from historical memory. The realization that early societies were capable of such extraordinary feats challenges the conventional narrative of linear progress, suggesting instead a history punctuated by advanced periods of human achievement that may have been obscured, lost, or deliberately forgotten. Ultimately, these hidden ancient megastructures demand a reconsideration of humanity's past. They demonstrate that early civilizations were capable of advanced engineering, astronomical observation, complex social organization, and cultural sophistication far beyond what mainstream history acknowledges. Their precision, scale, and global distribution imply that human ingenuity existed at a high level much earlier than traditionally thought. Each site stands as both a testament to human achievement and a challenge to prevailing assumptions about technological and social capabilities in antiquity. They invite ongoing exploration, critical inquiry, and reflection, reminding us that human history is far more intricate, mysterious, and extraordinary than conventional narratives suggest. These structures encourage an appreciation for the ingenuity of our ancestors and inspire the pursuit of knowledge that bridges the gap between the known and the hidden achievements of the ancient world. Across the vast expanse of human history, certain constructions stand as enduring enigmas, testaments to a level of engineering, planning, and astronomical understanding that seems almost impossibly advanced for the civilizations credited with their creation. Hidden ancient megastructures, many buried beneath layers of soil, sand, or water, are scattered across continents, challenging our assumptions about early human capability and forcing a reconsideration of the linear narratives often presented by conventional history. These sites are not mere monuments, they are complex creations that integrate mathematics, geometry, astronomy, and social organization in ways that continue to baffle researchers, archaeologists, and engineers alike. Their existence provokes questions that touch on the very origins of human ingenuity, the potential for lost civilizations, and the sophisticated knowledge that may have been acquired and then forgotten over millennia. In South America, the Tiwanaku complex and the adjacent Puma Punku site in Bolivia exemplify these remarkable achievements. At Puma Punku, enormous stone blocks, some exceeding 100 tons, are carved with astonishing precision and interlocked in intricate geometric patterns that defy conventional explanation. The blocks are shaped into a variety of forms, right angles, L-shaped, and T-shaped, complete with perfectly cylindrical holes and grooves. The level of precision suggests an understanding of mathematics, engineering, and material properties that is difficult to reconcile with the rudimentary tools traditionally attributed to Andean societies, such as stone hammers and copper chisels. The logistics of transporting these massive stones across uneven terrain, up terraces, and into their precise positions would have required meticulous planning, coordination, and possibly technologies or methods that have been lost to time. The fact that these structures remain stable and perfectly aligned after thousands of years indicates not only technical skill but also a sophisticated comprehension of physics, weight distribution, and structural integrity. The scale and precision of the Tiwanaku constructions become even more astonishing when considering the societal context. Organizing a workforce capable of moving, shaping, and assembling such massive stones requires hierarchical leadership, careful planning, and specialized knowledge. Archaeological evidence suggests that these societies had the capacity to mobilize large numbers of laborers over extended periods, possibly spanning multiple generations. This level of social organization implies a governance structure capable of long-term planning, resource management, and the maintenance of skilled artisans and engineers. Such capabilities challenge the common perception of early civilizations as technologically and socially simplistic, instead suggesting a society with advanced knowledge systems, both practical and conceptual. In Egypt, the Great Pyramid of Giza and its associated structures provide another striking example of ancient mastery. Constructed from millions of limestone and granite blocks, the Great Pyramid demonstrates extraordinary precision in alignment, leveling, and construction. The base is oriented almost perfectly to the cardinal points, while internal chambers are designed to distribute weight in a manner that preserves structural integrity across millennia. Ventilation shafts align with specific stars, demonstrating an awareness of astronomy integrated directly into the architectural design. The scale of these constructions, combined with their precise execution, suggests a civilization capable of extraordinary engineering, careful observation, and advanced knowledge of both mathematics and astronomy. Conventional explanations involving ramps, levers, and mass labor are insufficient to account for the level of precision achieved, leading some researchers to hypothesize lost techniques or knowledge that allowed the ancient Egyptians to accomplish feats still impressive by modern standards. Asia provides further evidence of advanced ancient construction. In India, the rock-cut temples of Ellora and Kailasa are particularly remarkable, as artisans carved entire freestanding structures directly from solid rock. These temples feature precise interiors, intricate decorative motifs, and structural stability that has withstood centuries of environmental stress. The process required not only exceptional manual skill but also a profound understanding of geometry, material properties, and long-term planning. The precise alignment of pillars, doorways, and chambers with celestial and terrestrial features suggests that these builders had an integrated worldview in which science, art, and spirituality were inseparable. Similarly, in China, ceremonial platforms, stone terraces, and monumental urban constructions demonstrate interlocking techniques, precise leveling, and alignment with cardinal points and celestial events, indicating advanced surveying methods and an understanding of structural principles comparable to those seen in South America and Egypt. The technology necessary to achieve these feats remains a subject of intense investigation and debate. Archaeologists have found limited direct evidence of the tools and methods used, leading to speculation about lost or unrecognized techniques. Experimental archaeology attempts to replicate these constructions using chisels, hammers, levers, and ramps, but these efforts often fail to match the precision and efficiency of the original structures. Some hypotheses propose advanced methods such as softening stone for shaping, refined measurement systems for alignment, or mechanical systems to move massive blocks with minimal effort. Regardless of the specific techniques, the outcomes, precisely cut, perfectly aligned, and structurally resilient constructions, indicate that ancient civilizations possessed knowledge and skills far more sophisticated than generally acknowledged. This evidence challenges the traditional timeline of human technological development and invites reconsideration of what early societies were capable of achieving. Astronomical alignment is another recurring feature of these ancient megastructures, reflecting the integration of scientific observation into architectural design. Many sites across South America, Egypt, and Asia are oriented according to the movements of the sun, moon, and stars, marking solstices, equinoxes, or significant celestial phenomena. Achieving such alignment would have required careful, long-term observation, precise mathematical calculation, and meticulous execution. The ability to incorporate astronomical knowledge into functional architecture indicates not only technical proficiency but also abstract thinking and a sophisticated understanding of the natural world. Aligning monumental structures with celestial events demonstrates that these societies were not only concerned with practical engineering but also sought to embed meaning, ritual, and cosmology into their constructions, creating enduring monuments that spoke to both the physical and spiritual worlds. The social organization underlying these constructions was extraordinary. Large-scale projects required careful coordination of labor forces, long-term planning across decades or generations, and consistent quality control. These societies had to manage resources efficiently, train skilled artisans, and sustain specialized workforces. The ability to execute such complex projects points to hierarchical governance, advanced administrative systems, and effective communication networks. The level of social sophistication implied by these constructions challenges assumptions about the simplicity of early civilizations, suggesting that human societies were capable of organization and collaboration on scales that rival even modern projects. This combination of social complexity and technical mastery highlights the integrated nature of knowledge, labor, and culture in the creation of monumental architecture. Durability and resilience are hallmarks of these megastructures. Many have survived thousands of years of environmental stresses, including earthquakes, floods, erosion, and human activity, while maintaining structural integrity. Builders demonstrated empirical knowledge of engineering principles such as weight distribution, interlocking construction, and foundation stabilization, ensuring the longevity of their work. The enduring nature of these constructions reflects foresight, intelligence, and technical skill, demonstrating that ancient societies prioritized permanence and resilience. The ability to design structures capable of withstanding the forces of nature over millennia underscores the sophistication of these civilizations and emphasizes the advanced understanding of materials and mechanics that they possessed. The cultural and symbolic significance of these megastructures is equally profound. Many incorporate sacred geometry, astronomical alignment, and symbolic motifs that convey religious, philosophical, and societal values. These structures were not merely functional, they were expressions of worldview, designed to communicate knowledge, reinforce social hierarchies, and embody cultural identity. The integration of practical engineering with spiritual and symbolic meaning suggests a holistic approach to construction, where art, science, and ritual were inseparable. The intentionality embedded in these structures indicates that ancient societies understood the power of architecture as a medium to transmit knowledge, values, and identity across generations, creating monuments that endure both physically and culturally. Encountering these megastructures evokes deep emotional responses, combining awe, wonder, and a sense of mystery. Observing massive stones precisely cut and interlocked, aligned with celestial phenomena, and executed with remarkable precision inspires admiration for human ingenuity. At the same time, these achievements provoke questions about lost knowledge, forgotten technologies, and civilizations whose accomplishments appear to have vanished from the historical record. The realization that societies thousands of years ago could achieve feats still impressive today challenges the conventional narrative of linear technological progression and encourages a re-evaluation of human potential and creativity. These structures serve as reminders that the story of human history is far more complex and remarkable than traditional accounts suggest. Ultimately, the hidden ancient megastructures scattered across the globe compel a fundamental reassessment of humanity's past. They demonstrate that early civilizations were capable of advanced engineering, astronomical observation, complex social organization, and cultural sophistication far beyond conventional expectations. Their scale, precision, and distribution imply that human ingenuity existed at a high level much earlier than mainstream history acknowledges. Each site stands as a testament to human achievement and a challenge to prevailing assumptions, urging exploration, inquiry, and reflection. They remind us that human history is not a linear progression of gradual improvement but a tapestry of extraordinary accomplishments, lost knowledge, and enduring mysteries that continue to inspire and challenge our understanding of the ancient world. These constructions highlight the ingenuity, resilience, and vision of our ancestors, providing both a window into a past filled with remarkable capabilities and a mirror reflecting the enduring human quest for mastery, knowledge, and meaning. Across the expanse of human history, certain constructions stand out not only for their sheer size but also for their sophistication, precision, and enduring mystery. These hidden ancient megastructures, often buried beneath centuries of sediment, sand, or vegetation, represent a level of architectural, engineering, and astronomical knowledge that continues to challenge modern understanding. Their existence implies that civilizations long before recorded history possessed advanced technical skills, complex social organization, and a deep understanding of mathematics and the natural world. From the Andes to Egypt, from India to East Asia, these constructions demand a re-evaluation of what early humans were capable of achieving, raising profound questions about the potential for lost knowledge, forgotten civilizations, and extraordinary technological capabilities that may have existed millennia before modern science and engineering as we know them. In South America, the Tiwanaku complex in Bolivia and its enigmatic subsite Puma Punku exemplify this advanced ancient knowledge. At Puma Punku, colossal stone blocks, some weighing over 100 tons, are cut with a precision that defies the traditional understanding of prehistoric technology. The stones are interlocked in intricate geometrical patterns, featuring perfectly straight edges, precise right angles, and cylindrical holes drilled with remarkable uniformity. Transporting these massive stones from distant quarries and positioning them accurately within the complex would have required not only incredible physical labor but also sophisticated planning, engineering insight, and possibly techniques that remain unknown to this day. The precision of the cuts and alignments suggests an understanding of geometry, physics, and material science far beyond what is typically attributed to Andean civilizations of that era. These constructions challenge the notion that technological advancement occurs in a linear progression, revealing a past in which human ingenuity reached extraordinary heights, only to be obscured by time. The Great Pyramid of Giza in Egypt represents another pinnacle of ancient achievement. Constructed from millions of limestone and granite blocks, the pyramid exhibits an astonishing level of precision in alignment, leveling, and structural engineering. Its base is aligned almost perfectly to the cardinal points, while internal chambers are designed to bear enormous weight and withstand environmental stress over millennia. Ventilation shafts appear aligned with specific stars, indicating an integration of astronomical knowledge into the architecture. Traditional theories suggest the use of ramps, levers, and large labor forces to construct the pyramids, yet these explanations struggle to account fully for the efficiency, precision, and complexity of the assembly. The pyramid reflects not only technical mastery but also a comprehensive understanding of mathematics, astronomy, and logistics. Its construction implies a civilization capable of executing large-scale projects with meticulous planning and scientific insight, a capability that continues to astonish modern engineers and archaeologists. Asia offers further evidence of advanced ancient construction techniques. In India, the rock-cut temples of Ellora and Kailasa are particularly remarkable. Entire freestanding temples were carved directly from solid rock, featuring precise interiors, ornamental detail, and structural stability. Achieving such feats would have required not only exceptional manual skill but also an in-depth understanding of geometry, stone properties, and engineering principles. Similarly, in China, ceremonial platforms, terraces, and monumental urban constructions display precise leveling, interlocking stone techniques, and alignments with cardinal directions and celestial events. These similarities across vast geographical distances suggest either independent development of comparable technological expertise or the possibility of knowledge transfer through unknown channels, hinting at the existence of sophisticated civilizations whose influence may have been global or at least far-reaching. The recurrence of such precision and scale across continents indicates that the knowledge embedded in these constructions was both advanced and deliberate, reflecting a level of intelligence, planning, and observation that modern historians are only beginning to fully appreciate. The tools and methods used to create these megastructures remain a subject of debate. While experimental archaeology has attempted to replicate these achievements using simple tools like stone hammers, copper chisels, levers, and ramps, these attempts often fall short of reproducing the precision, scale, and efficiency of the original works. Some scholars propose that ancient builders may have employed advanced, now lost technologies or methods, such as softening stone through chemical or mechanical processes, employing highly refined surveying techniques, or utilizing mechanical leverage systems unknown today. Regardless of the specific techniques, the outcome is undeniable: structures of staggering precision and durability, built to endure for millennia. This suggests that the ancient builders possessed a level of technical expertise and problem-solving ability that modern societies continue to find astonishing. Astronomical alignment is a recurring feature in these constructions, revealing the depth of scientific understanding embedded in their design. Many of these structures are oriented to the movements of the sun, moon, and stars, often marking solstices, equinoxes, or other significant celestial events. Achieving such alignments requires long-term observation, precise mathematical calculation, and meticulous planning. The integration of astronomical knowledge into architecture indicates that ancient civilizations were capable of abstract thought and sophisticated scientific observation. Aligning monumental constructions with cosmic phenomena reflects a worldview in which human activity, architecture, and the cosmos were interconnected, with structures serving functional, ceremonial, and symbolic purposes simultaneously. This interweaving of practical, spiritual, and observational knowledge underscores the intellectual sophistication of these ancient societies and challenges conventional assumptions about prehistoric cognition. Social organization played a crucial role in enabling these monumental projects. Coordinating large labor forces, ensuring consistent quality of workmanship, and sustaining construction efforts over decades or even generations required advanced administrative systems, hierarchical leadership, and specialized knowledge. These civilizations were capable of managing vast resources, training skilled artisans, and maintaining logistical coherence across long-term projects. The level of social sophistication implied by these constructions demonstrates that these societies were not only technologically advanced but also culturally and politically capable of executing complex, large-scale endeavors. This intertwining of social and technical expertise highlights the holistic approach of these ancient civilizations to problem-solving, planning, and execution, revealing a level of organization that is as impressive as the physical constructions themselves. The durability and resilience of these megastructures are extraordinary. Many have withstood earthquakes, floods, erosion, and the passage of millennia while maintaining their structural integrity. Builders clearly understood principles of weight distribution, interlocking construction, and foundation stabilization, ensuring that these works could endure environmental pressures over centuries. The emphasis on longevity demonstrates foresight, intelligence, and mastery of material properties, suggesting that ancient builders approached construction not merely as a temporary task but as a lasting legacy. These enduring monuments are tangible evidence of the sophistication, foresight, and ingenuity of ancient civilizations, and they continue to inspire both admiration and inquiry into the methods employed to achieve such resilience. Cultural and symbolic significance is deeply embedded in these megastructures. Many incorporate sacred geometry, astronomical alignment, and symbolic motifs that convey religious, philosophical, and societal values. These constructions were not simply utilitarian, they were deliberate expressions of worldview, intended to communicate knowledge, reinforce social hierarchies, and embody cultural identity across generations. By integrating technical mastery with spiritual and symbolic meaning, these societies created monuments that functioned as repositories of knowledge, ritual observatories, and cultural landmarks. The combination of practical engineering and philosophical intent highlights a sophisticated understanding of the human experience, where science, art, and spirituality were inseparably intertwined. Encountering these ancient megastructures evokes profound emotional responses, combining awe, admiration, and an unsettling sense of mystery. Observing massive stones cut with extraordinary precision, aligned with cosmic phenomena, and engineered to endure millennia inspires admiration for human ingenuity. Simultaneously, the existence of these achievements raises questions about lost knowledge, forgotten technologies, and civilizations whose accomplishments appear to have vanished from historical memory. The recognition that societies thousands of years ago were capable of feats that still challenge modern understanding forces a re-evaluation of human potential and the complexity of early civilizations. These structures suggest that the traditional narrative of human progress as a linear, gradual process may be incomplete, ignoring periods of extraordinary innovation and achievement that remain poorly understood or entirely unknown. Ultimately, these hidden ancient megastructures compel a radical reassessment of humanity's past. They demonstrate that early civilizations were capable of advanced engineering, complex social organization, astronomical observation, and cultural sophistication far beyond what mainstream history often acknowledges. Their precision, scale, and global distribution imply that human ingenuity existed at an advanced level much earlier than previously thought. Each site stands as both a testament to human achievement and a challenge to prevailing assumptions about historical capabilities, urging ongoing exploration, critical inquiry, and reflection. These constructions reveal that human history is not merely a linear progression but a tapestry of extraordinary accomplishments, lost knowledge, and enduring mysteries that continue to inspire, challenge, and humble modern understanding. They underscore the remarkable vision, creativity, and resilience of our ancestors, illuminating a past far richer, deeper, and more extraordinary than conventional narratives suggest, and inviting a re-evaluation of the untold stories of human civilization. Across the world, the presence of hidden ancient megastructures challenges our conventional understanding of human history, technology, and civilization. These constructions, often enormous in scale and astonishingly precise, are scattered across continents, yet they share remarkable similarities in engineering, design, and alignment with celestial phenomena. From South America to Egypt, from India to China, these sites suggest that ancient societies possessed not only technical skill but also sophisticated knowledge of mathematics, astronomy, and structural engineering. The very existence of these monuments forces a reconsideration of what humanity was capable of achieving thousands of years ago and raises compelling questions about lost knowledge, forgotten civilizations, and technological abilities that may have existed far earlier than traditionally assumed. In South America, the Tiwanaku complex and the adjacent site of Puma Punku in Bolivia stand as extraordinary examples of ancient ingenuity. Puma Punku, in particular, contains massive stone blocks weighing over 100 tons, precisely cut and interlocked with incredible accuracy. The stones are shaped into complex geometric forms, L-shaped, T-shaped, and right angles, with perfectly straight edges and cylindrical holes drilled with uniformity that suggests a level of craftsmanship well beyond what conventional tools of the time could produce. Transporting these massive stones from distant quarries across rugged terrain, lifting them into position, and assembling them with such precision would have required not only advanced engineering knowledge but also exceptional organizational and logistical skills. These constructions reveal a deep understanding of geometry, weight distribution, and material properties that remains astonishing even by modern standards. The precision and durability of the stones indicate that the builders had mastered techniques to shape and align materials in ways that modern archaeologists and engineers continue to study with awe and intrigue. Similarly, in Egypt, the Great Pyramid of Giza and other pyramidal structures demonstrate an extraordinary level of technical and organizational mastery. Built from millions of limestone and granite blocks, the Great Pyramid exhibits near-perfect alignment with the cardinal points and features internal chambers designed to distribute weight and withstand environmental stresses over thousands of years. Ventilation shafts and passageways appear to align with specific stars and celestial events, indicating that the builders had an advanced understanding of astronomy integrated directly into their architectural plans. Traditional explanations, involving large labor forces, ramps, and levers, fail to fully account for the precision, scale, and efficiency of the construction. These monuments suggest that the ancient Egyptians had developed sophisticated surveying techniques, advanced logistical strategies, and a deep understanding of structural engineering principles that allowed them to achieve feats that continue to impress modern architects and engineers. In Asia, particularly in India and China, further examples of sophisticated ancient engineering emerge. The rock-cut temples of Ellora and Kailasa in India were carved directly from solid rock, creating freestanding structures with intricate interiors, ornamental carvings, and structural stability. These projects required extensive planning, knowledge of stone properties, and precise geometric calculations. Similarly, in China, ceremonial platforms, terraces, and urban constructions reveal careful leveling, interlocking stone techniques, and alignment with celestial and cardinal directions. The recurrence of precise construction methods across distant regions suggests either a remarkable coincidence, independent invention of similar techniques, or, more intriguingly, a possibility of knowledge transfer across civilizations in ways that remain unexplained. These similarities indicate that advanced architectural and engineering knowledge was not isolated to one culture but may have been part of a broader, interconnected human understanding that has largely been lost to history. The technological abilities required for these constructions continue to provoke debate. Experimental archaeology has attempted to replicate the methods used to cut, transport, and position massive stones using rudimentary tools such as stone hammers, chisels, and levers. However, these attempts often fail to achieve the level of precision and efficiency observed in the original structures. Some researchers hypothesize that lost technologies may have been employed, including techniques for softening stone, advanced surveying instruments, or mechanical systems to move heavy blocks with minimal effort. Regardless of the specific methods used, the results are undeniable. These constructions demonstrate a level of knowledge, skill, and ingenuity that far exceeds what is typically attributed to early human civilizations. The ability to conceptualize, plan, and execute these projects implies not only physical capability but also cognitive sophistication, mathematical understanding, and a systematic approach to problem-solving that rivals modern engineering. Astronomical alignment is a prominent and consistent feature of these ancient structures. Across continents, many constructions are deliberately oriented in relation to the movements of the sun, moon, and stars, often marking solstices, equinoxes, or other significant celestial events. Achieving such alignment would have required long-term observation, precise measurement, and careful planning. The integration of celestial knowledge into architecture suggests that these societies possessed an advanced understanding of mathematics and astronomy and were capable of applying this knowledge practically. Aligning monumental constructions with cosmic phenomena also indicates a worldview in which human activity, architecture, and the cosmos were deeply interconnected, blending practical engineering with spiritual and ceremonial significance. These alignments were not arbitrary. They reflect deliberate decisions informed by observation, calculation, and a sophisticated understanding of natural cycles. Social organization played an equally critical role in enabling the construction of these megastructures. Coordinating large labor forces, ensuring quality control, and sustaining multi-decade or multi-generational projects required hierarchical leadership, advanced administrative systems, and logistical expertise. These societies had to manage resources, train artisans, and maintain long-term construction schedules, demonstrating a level of social sophistication that challenges traditional perceptions of early civilizations. The interplay between organizational capacity and technical skill underscores the holistic nature of these societies. Engineering, planning, and culture were inseparable, with monumental architecture serving as both a functional and symbolic testament to their collective knowledge and capability. Durability and resilience are among the most remarkable features of these constructions. Many have survived earthquakes, floods, erosion, and the passage of millennia while retaining structural integrity. Builders employed empirical knowledge of engineering principles such as interlocking construction, weight distribution, and foundation stabilization to ensure longevity. The endurance of these structures reflects not only technical mastery but also foresight and intentionality. They were designed to last, serving as lasting legacies that could communicate cultural identity, technological knowledge, and societal values across generations. This emphasis on permanence highlights the ingenuity and vision of these ancient civilizations, illustrating a profound understanding of materials, mechanics, and long-term planning. The cultural and symbolic significance of these megastructures is equally profound. Many incorporate sacred geometry, astronomical alignment, and symbolic motifs that convey religious, philosophical, and societal values. These constructions were intended to communicate meaning, reinforce social hierarchies, and embody cultural identity across generations. By combining functional engineering with spiritual and symbolic purpose, these civilizations created monuments that were not merely utilitarian but also deeply expressive, reflecting an integrated worldview in which art, science, and ritual were inseparable. The intentionality behind these designs demonstrates that these societies understood architecture as a medium for transmitting knowledge, cultural values, and spiritual principles, creating enduring legacies that resonate to this day. Encountering these megastructures evokes powerful emotional responses. Observing massive stones cut with remarkable precision, interlocked with geometric sophistication, and aligned with celestial phenomena inspires awe at human ingenuity. At the same time, their existence provokes questions about lost knowledge, forgotten technologies, and civilizations whose achievements appear to have vanished from historical memory. The realization that societies thousands of years ago could accomplish feats still difficult to replicate today challenges conventional narratives of linear human progress. It suggests that human history is punctuated by extraordinary periods of innovation, ingenuity, and achievement that are often obscured or forgotten over time. These structures invite reflection, curiosity, and a reconsideration of what is possible when intellect, vision, and collaboration converge on a monumental scale. Ultimately, hidden ancient megastructures compel a reassessment of humanity's past. They demonstrate that early civilizations were capable of advanced engineering, complex social organization, astronomical observation, and cultural sophistication far beyond conventional expectations. The scale, precision, and global distribution of these sites indicate that human ingenuity existed at levels much higher and much earlier than mainstream history acknowledges. Each structure stands as both a testament to human achievement and a challenge to prevailing assumptions, urging continued exploration, study, and reflection. These constructions reveal a past rich with ingenuity, resilience, and vision, illustrating that human history is not a simple linear progression but a tapestry of extraordinary accomplishments, lost knowledge, and enduring mysteries. They remind us of the incredible potential of our ancestors and inspire a deeper appreciation for the complexity, creativity, and intelligence that have shaped human civilization throughout the ages. Across the continents, hidden ancient megastructures continue to challenge conventional historical narratives, forcing us to reconsider the sophistication of early civilizations and their mastery of engineering, astronomy, and organizational capability. These monumental constructions, often buried beneath centuries of sand, soil, and sediment, are remarkable not only for their scale but for the precision, complexity, and foresight embedded within their design. They span continents, from the Andes to Egypt, from India to China, and each provides compelling evidence that human ingenuity was far more advanced in antiquity than mainstream history has traditionally acknowledged. The very existence of these structures raises profound questions about lost technologies, forgotten civilizations, and the depth of knowledge possessed by societies that predate written history, suggesting that humanity's past is far richer and more complex than conventional timelines would suggest. In South America, the Tiwanaku complex and Puma Punku in Bolivia exemplify these extraordinary capabilities. At Puma Punku, massive stone blocks, some weighing over 100 tons, are cut with an astonishing level of precision and interlocked in complex geometric patterns that appear impossible to replicate using tools historically available to Andean societies. These stones are shaped into right angles, L-shaped and T-shaped forms, with perfectly straight edges and cylindrical holes drilled uniformly, demonstrating a mastery of geometry, material properties, and spatial reasoning that defies conventional explanation. Transporting these colossal stones across rugged terrain, positioning them accurately, and assembling them with such precision would have required meticulous planning, advanced engineering knowledge, and highly coordinated labor. Experimental archaeology has attempted to replicate these feats with primitive tools, yet even the most careful efforts fall short, highlighting the extraordinary skill and knowledge of the original builders. The precision of the cuts, the alignment of the structures, and the interlocking construction suggest a sophisticated understanding of physics and engineering principles, evidence of a level of technical mastery that seems incongruous with what is traditionally known about pre-Columbian civilizations. In Egypt, the Great Pyramid of Giza and its surrounding monuments provide another striking example of ancient expertise. Constructed from millions of limestone and granite blocks, the Great Pyramid demonstrates an exceptional degree of precision in both alignment and leveling, with its base oriented almost perfectly to the cardinal points. Internal chambers are engineered to distribute immense weight and resist collapse over thousands of years, while ventilation shafts are aligned with specific stars, integrating astronomical observation into architectural design. Traditional explanations, relying on ramps, levers, and massive labor forces, fail to fully account for the speed, accuracy, and structural sophistication evident in the construction. The Great Pyramid suggests that the ancient Egyptians possessed advanced surveying techniques, a deep understanding of structural engineering, and the ability to plan and execute projects on a monumental scale. This level of technical proficiency challenges conventional historical assumptions and underscores the possibility that much of the knowledge required to build such monuments has been lost or deliberately obscured over time. In India, the rock-cut temples of Ellora and Kailasa illustrate a similarly extraordinary mastery of engineering and artistic skill. These structures were carved directly from solid rock, creating freestanding temples with intricate interiors, detailed ornamentation, and remarkable structural stability. Achieving this required not only manual dexterity but also a sophisticated understanding of geometry, stone properties, and load-bearing principles. Similarly, in China, ceremonial platforms, terraces, and urban constructions reveal precise leveling, interlocking techniques, and alignment with both cardinal directions and celestial phenomena. The recurrence of these advanced construction methods across distant civilizations suggests either an improbable convergence of independent technical innovation or the possibility of knowledge transfer between cultures in ways that remain unexplained. These similarities indicate that the construction knowledge embedded within these megastructures was not only advanced but also deliberate, reflecting a high degree of planning, observation, and mastery over natural materials and forces. The technological capabilities required for such constructions remain a subject of intense study and speculation. Archaeologists have found limited evidence of the tools or methods employed, making it difficult to fully understand how ancient builders achieved such precision. Experimental archaeology has attempted to replicate these constructions using rudimentary tools such as stone hammers, copper chisels, levers, and ramps, yet these experiments rarely reach the level of efficiency or accuracy seen in the originals. Some researchers have proposed the existence of lost technologies or methods, including techniques to soften stone, advanced surveying and measurement instruments, or mechanical systems to transport massive blocks with minimal friction. Regardless of the specific methods employed, the physical evidence demonstrates that these civilizations possess technical knowledge and problem-solving abilities far beyond what is typically recognized in mainstream historical accounts. Astronomical alignment is a hallmark of many of these megastructures, demonstrating a sophisticated understanding of celestial movements. Across continents, these constructions are deliberately oriented according to the positions of the sun, moon, and stars, often marking solstices, equinoxes, or other significant celestial events. Achieving such alignment would have required long-term observation, careful measurement, and precise execution during construction. The integration of astronomical knowledge into architecture indicates that ancient civilizations possessed not only practical engineering skills but also advanced mathematical understanding and abstract thinking. Aligning monumental constructions with cosmic phenomena reflects a worldview in which architecture, human activity, and the cosmos were intricately connected, blending functional, ceremonial, and symbolic purposes. These alignments were intentional, representing a deliberate fusion of science, spirituality, and cultural expression that continues to intrigue modern scholars. Social organization was critical in the construction of these megastructures. Coordinating large workforces, managing resources, maintaining quality control, and sustaining long-term construction projects required hierarchical leadership, administrative sophistication, and logistical expertise. These civilizations were able to mobilize labor, train skilled artisans, and execute projects over decades or even generations. The level of social and organizational capability implied by these constructions challenges traditional assumptions about the simplicity of early human societies, highlighting the integrated nature of technology, governance, and cultural ambition. The interplay between social structure and technical mastery reveals that these civilizations were capable of orchestrating complex, multi-generational endeavors with precision, demonstrating a sophistication that rivals modern engineering projects. Durability and resilience are among the most striking aspects of these ancient structures. Many have endured thousands of years of earthquakes, floods, erosion, and human interference while maintaining structural integrity. Builders clearly understood principles such as interlocking construction, weight distribution, and foundation stabilization, ensuring the longevity of their work. The enduring nature of these megastructures reflects foresight, intelligence, and technical expertise, demonstrating that these societies approached construction not merely as a temporary task but as a long-lasting legacy. These structures serve as tangible evidence of the ingenuity, vision, and practical knowledge of ancient civilizations, illustrating a level of engineering and planning that continues to impress even in the modern age. The cultural and symbolic significance of these constructions is equally profound. Many incorporate sacred geometry, astronomical alignment, and symbolic motifs, conveying religious, philosophical, and societal values. These structures were designed to communicate knowledge, reinforce social hierarchies, and embody cultural identity across generations. By integrating functional engineering with spiritual and symbolic meaning, ancient builders created monuments that were simultaneously utilitarian, ceremonial, and deeply meaningful. This holistic approach demonstrates that these societies understood architecture as a medium for transmitting knowledge, cultural values, and spiritual concepts, creating enduring legacies that resonate across centuries. The intentionality of their design underscores a deep understanding of the human experience, combining practicality, art, and cosmology in a manner rarely seen in modern construction. Encountering these megastructures evokes awe and contemplation. Observing massive stones cut with extraordinary precision, interlocked in complex geometric patterns, and aligned with celestial phenomena inspires admiration for the ingenuity of ancient humans. Simultaneously, the existence of these achievements raises questions about lost knowledge, forgotten technologies, and civilizations whose accomplishments seem to have vanished from history. Recognizing that societies thousands of years ago were capable of feats still difficult to replicate today forces a re-evaluation of conventional historical narratives. It suggests that human progress is not linear but punctuated by extraordinary bursts of innovation and ingenuity, much of which has been obscured by time or lost entirely. Ultimately, hidden ancient megastructures demand a reassessment of humanity's past. They reveal civilizations capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional assumptions. The scale, precision, and global distribution of these sites indicate that human ingenuity existed at an advanced level much earlier than previously acknowledged. Each structure stands as a testament to human achievement and a challenge to prevailing assumptions about technological and social capabilities in antiquity. These constructions illuminate a past rich in intelligence, foresight, and creativity, reminding us that human history is not merely a linear progression but a complex tapestry of remarkable accomplishments, lost knowledge, and enduring mysteries that continue to inspire, challenge, and humble modern understanding. They are evidence of a past in which human potential was extraordinary, offering both inspiration and a profound invitation to re-examine the untold stories of our ancient ancestors. Across the ancient world, hidden megastructures continue to challenge the very foundations of our understanding of human history, technology, and civilization. These colossal constructions, often buried beneath centuries of sediment, sand, or vegetation, are remarkable not merely for their size but for the precision, sophistication, and foresight inherent in their design. They are found on every continent, from the Andes in South America to the deserts of Egypt, from the mountains of India to the plains of China. Each structure represents not just a technical accomplishment but a profound demonstration of knowledge in mathematics, geometry, astronomy, and engineering that remains extraordinary even by modern standards. The existence of these megastructures compels us to reconsider conventional historical timelines and question what humanity was capable of achieving long before the age of written records, advanced metallurgy, or industrial machinery. In South America, the Tiwanaku complex and the enigmatic site of Puma Punku in Bolivia provide a window into an ancient civilization whose technological capabilities continue to astonish researchers. At Puma Punku, enormous stone blocks, some exceeding 100 tons, are meticulously cut and interlocked with geometric precision. Many stones feature perfect right angles, L-shaped configurations, and cylindrical holes drilled with astonishing uniformity, evidence of an advanced understanding of geometry and material manipulation. The transportation of these massive stones from distant quarries, up steep terraces and across uneven terrain, represents an extraordinary logistical achievement. Experimental archaeology has attempted to replicate these feats using basic tools such as stone hammers, copper chisels, and simple levers, yet these methods fall dramatically short of achieving the precision and efficiency evident in the original constructions. The very act of designing, cutting, and assembling these blocks demonstrates that these ancient societies possessed knowledge of physics, material properties, and spatial reasoning that modern researchers are only beginning to grasp. Similarly, in Egypt, the Great Pyramid of Giza and other pyramidal monuments stand as enduring symbols of human ingenuity. Constructed from millions of limestone and granite blocks, the Great Pyramid demonstrates an extraordinary degree of precision in leveling, alignment, and structural design. Its base is nearly perfectly aligned to the cardinal points, while internal chambers are engineered to bear immense weight and resist collapse over thousands of years. Ventilation shafts appear to correspond with specific stars, suggesting that astronomical observation was integrated into the architectural plan. Traditional explanations invoking massive labor forces, ramps, and levers struggle to fully account for the speed, accuracy, and complexity of construction, indicating that the ancient Egyptians had developed surveying techniques, engineering principles, and logistical strategies that remain astonishing today. The pyramid is not merely a tomb or monument but a testament to a civilization that mastered architecture, mathematics, and astronomy in ways that challenge modern assumptions about ancient technological capability. In India, the rock-cut temples of Ellora and Kailasa further illustrate the extraordinary capabilities of ancient builders. Entire freestanding temples were carved directly from solid rock, forming intricate interiors and exteriors with remarkable attention to structural stability. This required not only exceptional manual skill but also a deep understanding of geometry, load distribution, and stone properties. These constructions could not have been achieved without careful planning, skilled artisans, and precise measurement over extended periods. In China, ceremonial platforms, terraces, and urban structures reveal precise leveling, interlocking stone techniques, and alignment with both cardinal directions and celestial events. The recurrence of advanced construction techniques across widely separated civilizations raises profound questions about knowledge transfer, the existence of sophisticated global networks, or the independent emergence of remarkably similar technical solutions. These parallels suggest that human ingenuity, when combined with necessity and vision, can lead to remarkably similar architectural and engineering outcomes, even across vast distances and cultures. The technological mastery required for these constructions remains a topic of intense debate. Archaeological evidence of the tools used is limited, making it difficult to determine exactly how ancient builders achieved such precision. Experiments attempting to replicate these megastructures with rudimentary tools consistently fail to reach the level of accuracy, scale, and efficiency demonstrated in the originals. Some scholars propose the possibility of lost technologies or techniques, such as methods to soften stone, highly accurate surveying instruments, or mechanical systems for moving enormous blocks with minimal friction. Regardless of the specific methods employed, the outcome is undeniable: structures of immense precision, durability, and complexity that demonstrate an unparalleled level of technical understanding. These achievements highlight a level of human cognitive and engineering capability in antiquity that has been largely underestimated or overlooked in conventional historical narratives. Astronomical alignment is a defining feature of many of these ancient constructions, revealing a sophisticated integration of science, spirituality, and architecture. Across continents, numerous sites are deliberately oriented according to the positions of the sun, moon, and stars, marking solstices, equinoxes, or other significant celestial events. Achieving such alignment would have required long-term observation, precise measurement, and meticulous planning, suggesting that these societies possessed not only practical engineering skills but also advanced mathematical understanding and abstract reasoning. The deliberate integration of astronomical knowledge into architecture reflects a worldview in which human activity, societal order, and the cosmos were intimately connected. The alignment of monuments with celestial phenomena is not coincidental, it represents an intentional fusion of science, spirituality, and cultural symbolism that imbues these constructions with a layered significance that extends far beyond their physical function. Social organization played an indispensable role in enabling these feats. Constructing massive, complex structures over decades or centuries required coordination of labor, administration of resources, and maintenance of skilled workforces. Hierarchical leadership, clear communication, and long-term planning were essential to manage these projects successfully. These civilizations were capable of sustaining multi-generational endeavors while ensuring consistent quality, highlighting a level of social sophistication that is often underappreciated in mainstream historical accounts. The interplay between social structure and technical expertise illustrates the integrated approach of these ancient societies, where governance, labor, and engineering were inseparable components of monumental achievement. Durability and resilience define these constructions as much as their size and precision. Many megastructures have survived millennia of earthquakes, floods, erosion, and human interference, retaining their structural integrity and, in many cases, their intended alignment. Builders clearly understood the principles of weight distribution, interlocking construction, and foundation stabilization, enabling these structures to endure environmental pressures over centuries. This longevity underscores foresight and technical mastery, revealing a culture that prioritized permanence and legacy. The enduring nature of these monuments serves as tangible proof of the intellectual and practical sophistication of ancient societies and demonstrates a level of craftsmanship and planning that continues to inspire awe in the modern world. Cultural and symbolic meaning was embedded within these structures. Many incorporate sacred geometry, astronomical alignment, and symbolic motifs that convey religious, philosophical, and societal principles. These constructions were designed not merely as functional or ceremonial sites but as repositories of knowledge, cultural identity, and spiritual significance. Integrating functional engineering with symbolic meaning illustrates that these societies viewed architecture as a medium for transmitting knowledge, reinforcing social hierarchy, and embodying collective values across generations. The deliberate precision and alignment of these constructions demonstrate a profound understanding of the interconnectedness of human experience, spiritual belief, and practical engineering. Encountering these megastructures evokes awe, wonder, and a profound sense of mystery. Observing massive stones cut with exacting precision, interlocked in complex patterns, and aligned with cosmic phenomena inspires admiration for human ingenuity. At the same time, their existence raises questions about lost knowledge, forgotten technologies, and civilizations whose extraordinary accomplishments appear to have vanished from historical memory. The realization that societies thousands of years ago were capable of feats still astonishing to modern engineers challenges linear narratives of human progress. It suggests that human history is punctuated by extraordinary periods of innovation and achievement that are often obscured or erased over time, leaving tantalizing traces for us to uncover. Ultimately, hidden ancient megastructures demand a radical reassessment of humanity's past. They reveal civilizations capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. The scale, precision, and global distribution of these sites indicate that human ingenuity existed at levels much higher and far earlier than commonly acknowledged. Each structure stands as a testament to human creativity and a challenge to prevailing assumptions about historical capability. These megastructures illuminate a past rich in knowledge, foresight, and technical mastery, revealing that human civilization is far older, more complex, and more capable than mainstream accounts suggest. They inspire exploration, critical inquiry, and reflection, reminding us that our ancestors achieved feats of extraordinary vision and skill, leaving behind legacies that continue to challenge and expand our understanding of the ancient world. Across the millennia, hidden ancient megastructures continue to stand as silent witnesses to the extraordinary ingenuity of early civilizations, challenging our modern understanding of human history and technological capability. These monumental constructions, often buried beneath layers of earth, sand, or vegetation, are remarkable not only for their immense scale but for the precision, planning, and knowledge required to create them. Found on nearly every continent, from the towering mountains of South America to the deserts of Egypt, from the subcontinent of India to the plains of China, these sites reveal that humanity's ancestors possessed an advanced understanding of engineering, mathematics, geometry, and astronomy that defies conventional explanations. Each structure is more than a mere collection of stones or bricks, it represents a sophisticated integration of science, artistry, and social organization, raising profound questions about lost knowledge, forgotten civilizations, and the extraordinary capabilities of societies that existed long before recorded history. In South America, the Tiwanaku complex and the enigmatic site of Puma Punku in Bolivia exemplify the advanced engineering skills of ancient peoples. Puma Punku is especially notable for its massive stone blocks, some weighing more than 100 tons, precisely cut and interlocked in geometric patterns of astounding complexity. Many of these stones feature perfect right angles, L-shaped forms, and cylindrical holes, drilled with extraordinary uniformity, suggesting a deep understanding of geometry, spatial reasoning, and material properties. The transportation of these colossal stones from distant quarries, maneuvering them across rugged terrain, and placing them with such meticulous precision would have required not only tremendous physical effort but also advanced planning, logistical organization, and perhaps even knowledge of techniques that have since been lost. Experimental archaeology has attempted to replicate these feats using simple tools such as stone hammers, copper chisels, and rudimentary levers, yet these efforts consistently fall short of achieving the accuracy, scale, and efficiency evident in the original constructions. The precision, durability, and interlocking design of these stones strongly indicate that the builders possessed not only practical skill but also theoretical understanding, blending mathematics, engineering, and artistic sensibility into structures that have endured for millennia. In Egypt, the Great Pyramid of Giza and its surrounding structures provide further evidence of extraordinary ancient capabilities. Constructed from millions of limestone and granite blocks, the Great Pyramid exhibits remarkable precision in alignment, leveling, and structural engineering. Its base is nearly perfectly aligned to the cardinal points, while internal chambers are engineered to bear immense weight, resist collapse, and maintain stability over thousands of years. Ventilation shafts appear aligned with particular stars, suggesting that astronomical knowledge was intentionally integrated into the architecture. Traditional explanations involving large labor forces, ramps, and levers often fail to account fully for the speed, accuracy, and sophistication of these constructions. The pyramids demonstrate that the ancient Egyptians possessed not only advanced surveying techniques and structural engineering expertise but also the ability to plan, coordinate, and execute complex projects with extraordinary precision. These structures are not merely tombs or monuments, they are enduring testaments to the technical and intellectual mastery of a civilization that seems to have achieved knowledge well ahead of its time. In India, the rock-cut temples of Ellora and Kailasa provide striking examples of monumental construction achieved through sheer skill and knowledge. Entire freestanding temples were carved directly from solid rock, creating intricate interiors, detailed ornamentation, and structural stability. Completing such feats required exceptional planning, knowledge of stone properties, geometric calculation, and careful execution over extended periods. Similarly, in China, ceremonial platforms, terraces, and urban constructions demonstrate precise leveling, interlocking techniques, and alignment with cardinal directions and celestial phenomena. The recurrence of advanced construction techniques across widely separated civilizations invites speculation about the possibility of knowledge transfer or independent emergence of highly sophisticated technical methods. The similarities suggest that ancient humans, regardless of geography, were capable of solving remarkably complex engineering problems using a combination of observation, experimentation, and ingenuity, achieving results that continue to baffle modern researchers. The technological knowledge required to achieve such constructions remains largely mysterious. Archaeological evidence of tools or techniques is limited, leaving modern researchers to rely on experimental reconstructions and theoretical models. Replicating these megastructures with primitive tools consistently fails to reach the same level of precision and efficiency. Some researchers hypothesize the use of lost technologies, advanced surveying instruments, mechanical systems for moving heavy blocks, or methods to alter the properties of stone. Regardless of the specific tools or techniques employed, the outcome is clear: structures of incredible precision, complexity, and durability that demonstrate an unparalleled mastery of engineering principles. These constructions challenge conventional assumptions about the cognitive and technical abilities of ancient societies, revealing that early humans possessed capacities often underestimated or ignored in mainstream historical narratives. Astronomical alignment is a defining feature of many ancient megastructures, revealing the sophisticated integration of scientific observation into architectural planning. Across continents, these sites are deliberately oriented to the movements of the sun, moon, and stars, often marking solstices, equinoxes, or other significant celestial events. Achieving such alignment required extended observation, precise measurement, and careful implementation during construction. The ability to integrate celestial knowledge into massive architectural projects indicates not only practical engineering skills but also abstract reasoning, mathematical understanding, and a capacity for long-term planning. Aligning monumental structures with cosmic events demonstrates a worldview in which human activity, architecture, and the cosmos were deeply interconnected. The intentionality behind these alignments illustrates that these societies did not merely construct for functional purposes but imbued their work with cultural, spiritual, and intellectual significance. Social organization played a critical role in the realization of these constructions. Managing large labor forces, allocating resources, maintaining skilled artisans, and sustaining long-term projects required hierarchical leadership, advanced administrative systems, and logistical expertise. Ancient civilizations were capable of mobilizing populations, coordinating multi-generational labor, and executing projects over decades or even centuries with remarkable consistency. The integration of social structure with technical capability underscores the complexity of these societies, revealing that their achievements were not merely the product of brute force but the result of careful planning, knowledge, and coordination. The combination of social sophistication, technical mastery, and cultural vision allowed these civilizations to produce enduring works that continue to inspire and perplex modern observers. Durability and resilience define these megastructures as much as their scale and precision. Many have withstood earthquakes, floods, erosion, and the passage of millennia, maintaining structural integrity and, in many cases, their intended celestial or geographical alignment. Builders clearly understood principles such as weight distribution, interlocking construction, and foundation stabilization. The long-term endurance of these structures demonstrates foresight, skill, and technical knowledge, emphasizing that ancient civilizations approached construction as a legacy designed to last for countless generations. Their resilience is a testament to the mastery of materials, engineering foresight, and practical intelligence, showcasing capabilities that continue to challenge modern architects and engineers. Cultural and symbolic significance is deeply embedded within these structures. Many incorporate sacred geometry, astronomical alignment, and symbolic motifs, conveying religious, philosophical, and societal meanings. These constructions were intended not merely as functional or ceremonial structures but as repositories of knowledge, cultural identity, and spiritual significance. By blending functional engineering with symbolic purpose, these societies created monuments that were simultaneously practical, ceremonial, and profoundly expressive. This holistic approach illustrates that ancient builders viewed architecture as a medium to transmit knowledge, reinforce social hierarchy, and embody collective values across generations. The integration of art, science, and spirituality demonstrates the depth and sophistication of these civilizations, highlighting a worldview in which human, natural, and cosmic systems were intimately intertwined. Encountering these megastructures evokes a profound sense of awe and contemplation. Observing massive stones cut with extraordinary precision, interlocked in complex geometric patterns, and aligned with celestial phenomena inspires admiration for human ingenuity. At the same time, these achievements provoke questions about lost knowledge, forgotten technologies, and civilizations whose extraordinary capabilities appear to have vanished from memory. The realization that societies thousands of years ago could accomplish feats still difficult to replicate today challenges linear narratives of human progress. It suggests that human history is punctuated by extraordinary bursts of innovation and achievement, much of which has been obscured, forgotten, or lost over time. Ultimately, hidden ancient megastructures compel a radical reassessment of humanity's past. They demonstrate civilizations capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. The scale, precision, and distribution of these sites indicate that human ingenuity existed at an advanced level far earlier than mainstream historical accounts acknowledge. Each megastructure stands as both a testament to human achievement and a challenge to prevailing assumptions, urging continued exploration, study, and reflection. These constructions illuminate a past rich in knowledge, vision, and capability, revealing a history far more intricate, complex, and extraordinary than conventional narratives suggest. They remind us that our ancestors were not primitive but possessed remarkable intelligence, foresight, and creativity, leaving behind legacies that continue to inspire, challenge, and expand our understanding of the ancient world. Across the vast expanse of human history, the hidden megastructures of ancient civilizations continue to defy explanation, challenging conventional narratives of technological development, societal sophistication, and the progression of human knowledge. These monumental constructions, many buried under centuries of earth, sand, or sediment, are remarkable not only for their sheer scale but also for the extraordinary precision, planning, and knowledge embedded in their design. From the highlands of South America to the deserts of Egypt, from the subcontinent of India to the plains of China, these structures reveal that ancient societies possessed an advanced understanding of engineering, mathematics, astronomy, and material science that continues to astonish researchers today. They are not mere monuments, they are enduring testaments to a level of human ingenuity that often seems incompatible with the tools and techniques traditionally attributed to their builders, prompting a re-evaluation of what is possible in the ancient world. In South America, the Tiwanaku complex and the enigmatic site of Puma Punku in Bolivia exemplify the extraordinary technological capabilities of early civilizations. At Puma Punku, enormous stone blocks, some exceeding 100 tons, are intricately cut and interlocked in geometric patterns that demonstrate astonishing precision. Many stones feature perfectly straight edges, right angles, L-shaped configurations, and cylindrical holes drilled with uniformity that defies conventional explanation. The logistics of transporting these massive stones from distant quarries, maneuvering them across rough terrain, and placing them with such exacting accuracy would have required advanced knowledge of physics, engineering, and organizational strategy. Experimental archaeology has attempted to replicate these achievements using simple tools such as stone hammers, copper chisels, and basic levers, yet these efforts consistently fall short, failing to account for the precision, efficiency, and scale evident in the original constructions. The complexity of Puma Punku suggests a civilization with an exceptional understanding of geometry, spatial reasoning, and material manipulation, creating structures that are as much works of intellectual achievement as they are physical marvels. In Egypt, the Great Pyramid of Giza further exemplifies the extraordinary capabilities of ancient builders. Constructed from millions of limestone and granite blocks, the pyramid demonstrates unparalleled precision in alignment, leveling, and structural engineering. Its base is aligned almost perfectly with the cardinal points, while internal chambers are engineered to bear immense weight and resist collapse over millennia. Ventilation shafts appear to correspond with specific stars, suggesting a sophisticated integration of astronomical knowledge into architectural planning. Conventional explanations involving massive labor forces, ramps, and levers struggle to fully account for the accuracy, speed, and complexity of construction. The Great Pyramid reveals that the ancient Egyptians possessed not only advanced surveying techniques and structural engineering expertise but also the ability to plan, coordinate, and execute monumental projects with extraordinary precision. The pyramid is not merely a tomb, it is a testament to the intellectual, technical, and organizational mastery of a civilization whose achievements continue to awe and challenge modern engineers and historians alike. In India, the rock-cut temples of Ellora and Kailasa represent similarly remarkable feats of ancient construction. These freestanding temples were carved directly from solid rock, creating intricate interiors, detailed ornamentation, and structurally stable complexes that have endured for centuries. The achievement required exceptional skill, a profound understanding of geometric principles, and careful planning to ensure both aesthetic precision and structural integrity. The level of expertise demonstrated in these carvings challenges modern assumptions about the capabilities of ancient craftsmen and indicates that sophisticated knowledge of materials and engineering principles existed far earlier than traditionally thought. Likewise, in China, ceremonial platforms, terraces, and monumental urban constructions display precise leveling, interlocking techniques, and careful alignment with cardinal directions and celestial events. The recurrence of these methods across geographically distant civilizations suggests either independent emergence of similar technological solutions or perhaps even the possibility of knowledge transfer through means that remain unknown, reinforcing the idea that advanced engineering and architectural knowledge may have been far more widespread in the ancient world than mainstream history acknowledges. The technological capabilities required for these constructions remain a topic of ongoing research and debate. Archaeologists and engineers continue to search for evidence of the tools, methods, and processes used to achieve such precision, but direct documentation or surviving tools are often scarce. Attempts to replicate these megastructures using primitive methods consistently fail to match the precision, efficiency, and scale of the original works. Some researchers suggest the use of techniques now lost to history, such as methods for softening or shaping stone, advanced measuring instruments, or mechanical systems for moving massive blocks with minimal friction. While the specifics remain speculative, the enduring reality is that these constructions demonstrate a level of knowledge, skill, and understanding that far exceeds what is typically credited to early human civilizations. They represent a fusion of intellectual, observational, and practical mastery that allowed societies to achieve feats still considered remarkable today. Astronomical alignment is a recurring and significant feature of these ancient structures, revealing the integration of scientific observation into architectural planning. Across continents, many of these constructions are deliberately oriented in relation to the movements of the sun, moon, and stars, marking solstices, equinoxes, and other significant celestial phenomena. Achieving such alignment required long-term observation, precise measurement, and careful execution during construction. This demonstrates not only practical engineering and architectural skill but also a sophisticated understanding of mathematics, timekeeping, and celestial mechanics. The alignment of monumental constructions with cosmic phenomena indicates a worldview in which human activity, societal order, and the cosmos were intimately connected. The deliberate incorporation of astronomical knowledge imbued these structures with cultural, spiritual, and scientific significance, transforming them into multidimensional monuments that served functional, ceremonial, and symbolic purposes simultaneously. Social organization was critical to the construction of these massive edifices. Managing labor forces, allocating resources, training skilled artisans, and sustaining projects over decades or even centuries required sophisticated administrative systems, hierarchical governance, and meticulous logistical planning. These societies demonstrated the ability to coordinate complex, multi-generational endeavors with precision, maintaining quality and consistency throughout construction. The integration of social structure with technical knowledge underscores the complexity of these ancient civilizations, showing that their monumental achievements were the product of collective organization, cultural ambition, and intellectual capability, not merely individual effort or brute force. The successful execution of such large-scale projects illustrates a holistic approach in which societal, technical, and cultural dimensions were interdependent and mutually reinforcing. Durability and resilience are among the most remarkable characteristics of these structures. Many have withstood earthquakes, floods, erosion, and the passage of thousands of years while maintaining structural integrity and often remaining aligned to their original astronomical or geographical specifications. Builders employed sophisticated techniques, including interlocking construction, weight distribution, and foundation stabilization, to ensure the long-term stability of their work. The enduring nature of these constructions reflects careful planning, technical foresight, and mastery of materials, demonstrating that these civilizations designed with the long view in mind, creating legacies that could survive countless generations. Their resilience is a testament to both the intelligence and the visionary thinking of their creators, highlighting an understanding of construction principles that remains relevant and impressive even in modern engineering contexts. Cultural and symbolic meaning was embedded within every aspect of these megastructures. Many incorporate sacred geometry, astronomical alignments, and symbolic motifs, conveying religious, philosophical, and societal principles. These constructions functioned not merely as functional spaces or ceremonial sites but as repositories of knowledge, cultural identity, and spiritual meaning. By integrating functional engineering with symbolic intent, these societies created monuments that were simultaneously practical, ceremonial, and intellectually profound. This holistic approach demonstrates that ancient civilizations viewed architecture as a medium for transmitting knowledge, reinforcing social cohesion, and embodying collective values across generations. The deliberate precision, alignment, and symbolic integration reveal a worldview in which science, art, and spirituality were inseparably intertwined. Encountering these ancient megastructures evokes awe, wonder, and a deep sense of mystery. Observing massive stones cut with extraordinary precision, interlocked in complex patterns, and aligned with celestial phenomena inspires admiration for human ingenuity. At the same time, their existence raises questions about lost knowledge, forgotten technologies, and civilizations whose extraordinary capabilities seem to have disappeared from historical memory. Recognizing that societies thousands of years ago were capable of feats still challenging to modern engineers forces a reconsideration of conventional narratives of linear human progress. These structures suggest that human history is punctuated by extraordinary periods of innovation and achievement that are often obscured, forgotten, or lost over time, leaving behind tantalizing traces for future generations to uncover. Ultimately, hidden ancient megastructures demand a profound reassessment of humanity's past. They reveal civilizations capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. The scale, precision, and global distribution of these sites indicate that human ingenuity existed at a level much higher and far earlier than mainstream historical accounts acknowledge. Each megastructure stands as both a testament to human achievement and a challenge to prevailing assumptions, urging exploration, critical study, and reflection. These constructions illuminate a past rich in knowledge, vision, and capability, revealing that human civilization is far more intricate, complex, and extraordinary than conventional narratives suggest. They remind us that our ancestors were not primitive but possessed remarkable intelligence, foresight, and creativity, leaving behind legacies that continue to inspire, challenge, and expand our understanding of the ancient world. Across the sweep of human history, hidden ancient megastructures stand as silent witnesses to extraordinary ingenuity, challenging modern assumptions about technological progression, societal sophistication, and the limits of early human capability. These monumental constructions, often buried beneath centuries of sand, soil, or vegetation, are remarkable not only for their immense scale but also for the extraordinary precision, foresight, and knowledge embedded in their design. Found across continents, from the Andes of South America to the deserts of Egypt, from the subcontinent of India to the vast plains of China, these structures reveal that ancient civilizations possessed an advanced understanding of engineering, mathematics, astronomy, and material science that continues to astonish archaeologists, engineers, and historians alike. Each site is more than a collection of stones or architectural forms, it is a testament to a sophisticated integration of science, artistry, and social organization, raising profound questions about lost knowledge, forgotten civilizations, and the remarkable capabilities of societies that existed long before the rise of recorded history. In South America, the Tiwanaku complex and the nearby site of Puma Punku in Bolivia offer extraordinary examples of ancient technological prowess. At Puma Punku, enormous stone blocks, some weighing over 100 tons, are cut and interlocked with astonishing geometric precision. Many of these stones display perfectly straight edges, precise right angles, L-shaped and T-shaped configurations, and cylindrical holes drilled with uniformity that remains difficult to explain even with modern technology. Transporting these massive stones from distant quarries, maneuvering them across uneven terrain, and positioning them with such meticulous accuracy would have required not only immense physical effort but also advanced knowledge of physics, engineering, and logistics. Experimental archaeology has attempted to recreate these feats using simple tools such as stone hammers, copper chisels, and basic levers, yet these attempts consistently fail to replicate the precision, efficiency, and scale evident in the original constructions. The design, cutting, and placement of these stones indicate a civilization with a profound understanding of geometry, material properties, and spatial reasoning, creating structures that were both functional and enduring masterpieces of technical ingenuity. In Egypt, the Great Pyramid of Giza serves as a further testament to the extraordinary capabilities of ancient builders. Constructed from millions of limestone and granite blocks, the pyramid demonstrates unparalleled precision in alignment, leveling, and structural engineering. Its base is nearly perfectly aligned with the cardinal points, while internal chambers are meticulously engineered to bear immense weight and resist collapse over millennia. Ventilation shafts align with specific stars, suggesting that astronomical observation was integral to the architectural plan. Conventional explanations, such as the use of large labor forces, ramps, and levers, often fail to account for the speed, accuracy, and structural sophistication of the project. The Great Pyramid reveals that the ancient Egyptians possessed not only advanced surveying and engineering expertise but also the capacity to plan, coordinate, and execute monumental projects with extraordinary precision. Far beyond serving as a tomb or monument, the pyramid represents the culmination of intellectual, technical, and organizational mastery in a civilization that continues to inspire and challenge modern scholarship. In India, the rock-cut temples of Ellora and Kailasa showcase similarly remarkable feats of construction and planning. Entire freestanding temples were carved directly from solid rock, creating interiors and exteriors of extraordinary intricacy, complete with detailed ornamentation and structural stability. Achieving such precision required exceptional skill, careful planning, and a deep understanding of stone properties, geometric principles, and load-bearing techniques. The complexity and scale of these structures indicate that Indian artisans and architects of the period had developed an advanced understanding of engineering, mathematics, and material science, demonstrating capabilities often underestimated in mainstream historical narratives. In China, ceremonial platforms, terraces, and urban constructions exhibit precise leveling, interlocking stone techniques, and alignment with both cardinal directions and celestial events. The recurrence of advanced construction methods across geographically disparate civilizations raises compelling questions about either independent development of highly sophisticated engineering techniques or possible transmission of knowledge through unknown networks. The similarity in precision, scale, and alignment among these civilizations suggests that advanced architectural and engineering knowledge was not isolated but may have been more widespread than previously acknowledged. The technological capabilities required for these constructions continue to provoke debate among scholars and engineers. Archaeological evidence of the tools and methods used is scarce, leaving much to conjecture and experimental reconstruction. Efforts to replicate these megastructures using simple, primitive tools consistently fall short of achieving the precision, efficiency, and scale observed in the original works. Some researchers posit the use of now-lost technologies or sophisticated methods such as chemical or mechanical softening of stone, advanced surveying instruments, or mechanical systems for moving massive blocks with minimal effort. Regardless of the specific techniques, the outcome is undeniable. These ancient constructions exhibit remarkable precision, complexity, and durability that challenge our understanding of what early human societies were capable of achieving. They reflect a remarkable fusion of intellectual mastery, technical skill, and practical problem-solving that remains inspirational and puzzling in the modern era. Astronomical alignment is a defining characteristic of many of these ancient megastructures, revealing the integration of scientific observation into architectural planning. Across continents, these constructions are deliberately oriented according to the positions of the sun, moon, and stars, marking solstices, equinoxes, and other significant celestial events. Achieving such alignment would have required long-term observation, precise measurement, and careful planning during construction, demonstrating that these civilizations possessed not only engineering and architectural skills but also advanced mathematical and astronomical understanding. The deliberate integration of celestial knowledge into the design of monumental architecture reflects a worldview in which human activity, societal order, and the cosmos were deeply interconnected. The alignment of these structures with celestial phenomena transformed them into multidimensional monuments that serve practical, ceremonial, and symbolic purposes simultaneously, showcasing the intellectual sophistication of their creators. Social organization was central to the realization of these monumental projects. Managing large labor forces, allocating scarce resources, training skilled artisans, and sustaining construction over decades or even centuries required highly developed administrative systems, hierarchical leadership, and meticulous logistical planning. Ancient civilizations demonstrated the ability to coordinate complex, multi-generational efforts with remarkable consistency and precision. The integration of social structure with technical capability reveals the complexity of these societies, showing that their monumental achievements were not the product of brute force alone but the result of careful planning, collective intelligence, and cultural ambition. The success of these large-scale projects illustrates a holistic approach in which governance, labor, and engineering were inseparable, allowing these civilizations to leave enduring legacies of unprecedented achievement. Durability and resilience are among the most remarkable aspects of these ancient constructions. Many have withstood earthquakes, floods, erosion, and the passage of thousands of years while maintaining structural integrity and often preserving alignment with original celestial or geographic markers. Builders employed advanced principles of interlocking construction, weight distribution, and foundation stabilization to ensure long-term stability. The enduring nature of these megastructures reflects foresight, engineering expertise, and practical intelligence, demonstrating that these civilizations built with a vision for longevity. Their resilience is a testament to both the intellectual and visionary capabilities of their creators, revealing an understanding of structural mechanics and material science that continues to impress modern engineers and architects. Cultural and symbolic meaning is embedded in every aspect of these structures. Many incorporate sacred geometry, astronomical alignments, and symbolic motifs that convey religious, philosophical, and societal principles. These constructions function not merely as functional or ceremonial sites but as repositories of knowledge, cultural identity, and spiritual meaning. By blending functional engineering with symbolic purpose, ancient civilizations created monuments that were simultaneously practical, ceremonial, and intellectually profound. This holistic approach demonstrates that architecture was considered a medium for transmitting knowledge, reinforcing social cohesion, and embodying collective values across generations. The precision, alignment, and symbolic integration of these structures reveal a worldview in which science, art, and spirituality were deeply interconnected, reflecting a civilization capable of seeing the physical and metaphysical as interwoven. Encountering these ancient megastructures evokes awe, wonder, and profound contemplation. Observing massive stones cut with extraordinary precision, interlocked in complex geometric patterns, and aligned with celestial phenomena inspires admiration for human ingenuity and vision. At the same time, the existence of these achievements provokes questions about lost knowledge, forgotten technologies, and civilizations whose extraordinary capabilities appear to have vanished from memory. Recognizing that societies thousands of years ago were capable of feats still difficult to replicate today forces a reconsideration of conventional narratives of linear human progress. These structures suggest that human history is punctuated by extraordinary periods of innovation and achievement that have been obscured, forgotten, or lost, leaving tantalizing traces for modern generations to explore. Ultimately, hidden ancient megastructures demand a profound reassessment of humanity's past. They reveal civilizations capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. The scale, precision, and global distribution of these constructions indicate that human ingenuity existed at an advanced level far earlier than mainstream historical accounts acknowledge. Each megastructure stands as both a testament to human achievement and a challenge to prevailing assumptions, inviting exploration, study, and reflection. These constructions illuminate a past rich in knowledge, vision, and capability, revealing a history far more intricate, complex, and extraordinary than conventional narratives suggest. They remind us that our ancestors were not primitive but possessed remarkable intelligence, foresight, and creativity, leaving legacies that continue to inspire, challenge, and expand our understanding of the ancient world. Across the expanse of ancient human history, hidden megastructures continue to awe and confound scholars, engineers, and explorers alike. These colossal constructions, scattered across continents and often buried under centuries of soil, sand, and vegetation, stand as enduring testaments to the extraordinary ingenuity, technical skill, and visionary thinking of civilizations long past. Unlike ordinary ruins, these structures are remarkable not merely for their size, but for the precision, foresight, and intellectual mastery embedded in every aspect of their design. From the towering stone complexes of South America to the monumental pyramids of Egypt, from the rock-hewn temples of India to the elaborate ceremonial constructions of China, these sites reveal that early human societies possessed an advanced understanding of mathematics, engineering, astronomy, and material science far beyond what mainstream history typically acknowledges. Each construction is not only a marvel of engineering but a symbol of sophisticated cognitive ability, social organization, and cultural expression that challenges conventional timelines of human development. In South America, the Tiwanaku complex and the enigmatic site of Puma Punku in Bolivia provide some of the clearest evidence of this advanced knowledge. Puma Punku, in particular, is a site of extraordinary engineering complexity. Massive stone blocks, some weighing well over 100 tons, are cut with remarkable precision and interlocked in geometric patterns that seem almost impossible to achieve with the tools known to have existed at the time. The stones display perfect right angles, L-shaped and T-shaped configurations, and cylindrical holes drilled with astonishing uniformity, demonstrating a deep understanding of geometry, material properties, and load-bearing principles. The transportation of these immense stones from distant quarries across uneven terrain, lifting them into place, and assembling them with such exacting precision would have required not only extraordinary physical effort but also advanced planning, coordination, and possibly technologies now lost to history. Experimental archaeology has attempted to replicate these feats using stone hammers, copper chisels, and basic levers, but even with painstaking effort, modern researchers consistently fall short of achieving the scale, efficiency, and precision of the original construction. The precision and complexity of Puma Punku suggest a civilization that was not only skilled in the practical application of engineering but also capable of abstract mathematical reasoning, spatial intelligence, and long-term planning. Similarly, in Egypt, the Great Pyramid of Giza stands as a monument to human ingenuity that has fascinated scholars for millennia. Constructed from millions of limestone and granite blocks, the Great Pyramid exhibits exceptional accuracy in alignment, leveling, and structural design. Its base is oriented almost perfectly to the cardinal points, while its internal chambers are meticulously engineered to withstand immense weight and remain stable over thousands of years. Ventilation shafts are aligned with particular stars, indicating a sophisticated integration of astronomical knowledge into architectural planning. Conventional explanations, such as the use of ramps, large labor forces, and simple levers, struggle to fully account for the precision, speed, and intricacy of construction. The Great Pyramid reflects not just practical skill but intellectual mastery, suggesting that the ancient Egyptians possessed advanced surveying techniques, a deep understanding of structural mechanics, and the ability to orchestrate large-scale projects with remarkable precision. Beyond its function as a tomb or monument, the Great Pyramid embodies a civilization's capacity for abstract thinking, long-term vision, and technical ingenuity that remains unparalleled in many respects. In India, the rock-cut temples of Ellora and Kailasa further exemplify the extraordinary achievements of ancient architects and craftsmen. Entire freestanding temples were carved directly from solid rock, forming complex interiors and elaborately detailed exteriors that remain structurally stable centuries after their construction. Such work required not only immense skill but also careful calculation, a sophisticated understanding of the properties of stone, and precise execution. The level of expertise and planning necessary to achieve these results highlights a mastery of engineering, geometry, and material science that challenges assumptions about the technological capabilities of ancient societies. In China, ceremonial platforms, terraces, and monumental urban complexes demonstrate equally advanced engineering. These structures feature precise leveling, interlocking construction techniques, and alignment with cardinal directions and celestial phenomena, suggesting a deep knowledge of surveying, mathematics, and astronomy. The striking parallels between construction techniques and architectural principles across widely separated civilizations raise compelling questions about whether these similarities arose independently or through the transmission of knowledge along ancient, yet unrecognized, networks of contact. Regardless of origin, these structures reflect a high degree of sophistication, ingenuity, and vision, revealing that ancient humans were capable of remarkable technical achievements on a global scale. The technological knowledge required to create these megastructures remains a topic of significant debate. Archaeological evidence of the specific tools and methods used is often limited, leaving much to speculation and experimentation. Replications using simple, primitive tools consistently fail to achieve the accuracy, efficiency, and scale of the original constructions. Some scholars suggest the use of now-lost techniques, potentially including methods for softening or shaping stone, advanced surveying devices, or mechanical systems for moving massive blocks with minimal friction. Regardless of the exact methods, the resulting structures demonstrate extraordinary precision, complexity, and durability. They reveal that ancient civilizations were capable of mastering engineering principles, material properties, and problem-solving approaches that modern humans find challenging to replicate, reflecting a level of cognitive and technical sophistication previously unacknowledged in mainstream history. Astronomical alignment is another hallmark of these ancient megastructures, revealing the integration of science, ritual, and architectural planning. Across continents, many constructions are deliberately oriented according to the positions of the sun, moon, and stars, marking solstices, equinoxes, and other celestial events. Achieving such alignments required careful observation, measurement, and execution over long periods, demonstrating a profound understanding of astronomy and mathematics. The deliberate incorporation of celestial knowledge into monumental architecture reflects a worldview in which human activity, societal order, and the cosmos were deeply interconnected. These alignments were intentional and precise, transforming the structures into living instruments that connected earthly civilizations to cosmic cycles, blending functionality with symbolism, spirituality, and scientific observation. Social organization played a crucial role in the execution of these monumental projects. Coordinating large labor forces, managing scarce resources, training skilled artisans, and sustaining long-term construction required highly developed administrative systems, hierarchical leadership, and meticulous logistical planning. These societies demonstrated the capacity to orchestrate multi-generational projects with remarkable consistency, ensuring precision and quality throughout decades or centuries of labor. The integration of social structure with technical and architectural mastery underscores the sophistication of these civilizations, revealing that their achievements were not merely the result of brute force but of intelligent planning, cultural ambition, and collective organization. Large-scale construction became a means of both asserting social cohesion and demonstrating technological prowess, showcasing an advanced understanding of both human and material resources. Durability and resilience are among the most striking aspects of these ancient constructions. Many have withstood earthquakes, floods, erosion, and the passage of millennia while maintaining structural integrity and, in some cases, precise alignment with celestial or geographical markers. Builders employed sophisticated engineering principles, such as interlocking construction, precise weight distribution, and foundation stabilization, to ensure longevity. The enduring nature of these megastructures reflects careful planning, technical foresight, and mastery of materials, illustrating a vision that extended far beyond the immediate needs of the society. Their resilience is a testament to the intellectual and practical brilliance of their creators, demonstrating that ancient civilizations were capable of constructing works that could endure the test of time in ways that continue to challenge modern engineering. Cultural and symbolic meaning was deliberately woven into these structures. Many incorporate sacred geometry, astronomical alignments, and symbolic motifs that convey religious, philosophical, and societal principles. These constructions were intended not only as functional or ceremonial spaces but also as repositories of knowledge, cultural identity, and spiritual significance. By blending functional engineering with symbolic intent, ancient builders created monuments that were simultaneously practical, ceremonial, and intellectually profound. Architecture became a medium through which knowledge, cultural values, and spiritual beliefs were transmitted across generations. The integration of art, science, and spirituality demonstrates that ancient societies conceived of human activity and the natural world as deeply interconnected, reflecting an advanced cognitive framework that continues to inspire awe. Encountering these megastructures evokes both wonder and profound reflection. Observing massive stones cut with extraordinary precision, interlocked in complex geometric patterns, and aligned with celestial phenomena inspires admiration for the technical skill and intellectual insight of ancient civilizations. At the same time, the existence of these achievements raises questions about lost knowledge, forgotten technologies, and societies whose extraordinary capabilities appear to have disappeared from historical memory. The realization that humans thousands of years ago were capable of feats still challenging to modern engineers forces a reconsideration of conventional narratives of linear progress. These structures suggest that human history is punctuated by extraordinary periods of innovation, creativity, and technical mastery, much of which has been obscured, forgotten, or lost over time. Ultimately, hidden ancient megastructures compel a profound reassessment of humanity's past. They reveal civilizations capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. The scale, precision, and global distribution of these sites indicate that human ingenuity existed at levels far higher and far earlier than mainstream historical accounts acknowledge. Each megastructure stands as both a testament to human achievement and a challenge to prevailing assumptions, urging continued exploration, study, and reflection. These constructions illuminate a past rich in knowledge, foresight, and capability, revealing a history far more complex, intricate, and extraordinary than conventional narratives suggest. They remind us that our ancestors were not primitive but possessed remarkable intelligence, creativity, and vision, leaving legacies that continue to inspire, challenge, and expand our understanding of the ancient world. Across the span of human history, hidden ancient megastructures remain among the most compelling and perplexing evidence of early civilizations' ingenuity, sophistication, and technical mastery. These colossal constructions, scattered across continents and frequently buried beneath centuries of earth, sand, or vegetation, are remarkable not only for their monumental scale but also for the precision, planning, and knowledge required to create them. From the highlands of South America to the deserts of Egypt, from the rock-hewn temples of India to the elaborate ceremonial complexes of China, these sites challenge our understanding of what humanity was capable of achieving thousands of years ago. They reveal civilizations that mastered engineering, mathematics, astronomy, and material science, often at levels that rival or surpass modern expectations, leaving behind legacies that continue to astonish and provoke inquiry. These structures are more than architectural feats, they are embodiments of knowledge, culture, and vision, prompting questions about lost technologies, forgotten traditions, and the true potential of early human societies. In South America, the Tiwanaku complex and the nearby site of Puma Punku in Bolivia stand as unparalleled examples of ancient technological accomplishment. Puma Punku is particularly extraordinary, featuring massive stone blocks, some weighing more than 100 tons, cut and interlocked with a precision that seems impossible given the tools traditionally attributed to the civilization that built them. Many stones exhibit perfectly straight edges, right angles, L-shaped and T-shaped configurations, and cylindrical holes drilled with a uniformity that continues to baffle engineers and archaeologists. Moving these stones from distant quarries, transporting them across rugged terrain, and positioning them with meticulous accuracy would have required not only tremendous physical effort but also an advanced understanding of physics, material properties, and logistics. Experimental archaeology has attempted to recreate these feats using copper chisels, stone hammers, ropes, and simple levers, yet even with significant effort, modern researchers fall short of reproducing the efficiency, scale, and precision achieved by the original builders. The design and execution of Puma Punku suggest a civilization that combined practical ingenuity with abstract mathematical reasoning, creating structures that were simultaneously functional, monumental, and enduring. In Egypt, the Great Pyramid of Giza remains one of the most striking testaments to ancient human capability. Constructed from millions of limestone and granite blocks, the pyramid demonstrates extraordinary precision in alignment, leveling, and structural engineering. Its base is almost perfectly aligned with the cardinal points, while internal chambers are engineered to bear immense weight and remain stable for thousands of years. Ventilation shafts are aligned with specific stars, indicating a sophisticated integration of astronomical observation into the architectural plan. Conventional explanations, such as the use of ramps, large labor forces, and basic tools, fail to account fully for the speed, accuracy, and intricate engineering evident in the pyramid's construction. The Great Pyramid exemplifies not only practical skill but also intellectual mastery, reflecting advanced surveying techniques, structural understanding, and the ability to plan and coordinate complex projects over long periods. Far beyond serving as a tomb or ceremonial monument, the pyramid embodies a civilization's capacity for abstract thought, precise execution, and long-term vision. In India, the rock-cut temples of Ellora and Kailasa offer further evidence of the extraordinary achievements of ancient architects and artisans. Entire temples were carved directly from solid rock, forming interiors and exteriors of exceptional intricacy, complete with ornate carvings, structurally stable halls, and elaborate facades. Accomplishing such work demanded not only technical skill but also advanced planning, a thorough understanding of the material properties of stone, and mastery of geometry and load-bearing principles. The level of expertise demonstrated in these constructions challenges assumptions about the technological capabilities of the period and highlights a sophistication that is often overlooked in mainstream historical narratives. In China, ceremonial platforms, terraces, and urban constructions exhibit similarly advanced engineering, featuring precise leveling, interlocking stone techniques, and alignment with cardinal directions and celestial events. The recurrence of advanced construction techniques across geographically disparate civilizations raises compelling questions regarding whether these similarities were the result of independent innovation or knowledge transfer through as yet unrecognized ancient networks. Either way, these structures reveal a remarkable global pattern of technical mastery, ingenuity, and vision in early human history. The technological capabilities demonstrated by these ancient megastructures continue to provoke debate among historians, archaeologists, and engineers. Direct evidence of the tools, techniques, and processes employed is often limited, leaving much to informed speculation and experimental replication. Modern attempts to recreate these constructions with primitive tools consistently fail to achieve the accuracy, scale, and efficiency of the original works. Some researchers posit the use of now-lost technologies, possibly including methods to soften or manipulate stone, advanced surveying instruments, or mechanical systems for moving enormous blocks with minimal friction. Regardless of the precise methods, the outcomes are undeniable: structures that exhibit extraordinary precision, complexity, and resilience, demonstrating cognitive and technical capabilities that remain difficult to explain using conventional historical frameworks. These constructions are not only feats of engineering but also reflections of intellectual mastery, long-term planning, and the ability to integrate knowledge across multiple domains. Astronomical alignment is a central feature of many ancient megastructures, revealing the integration of scientific observation, ritual, and architecture. Across continents, numerous constructions are deliberately oriented according to the positions of the sun, moon, and stars, marking solstices, equinoxes, and other significant celestial events. Achieving such alignment required extended observation, precise measurement, and careful planning during construction, indicating a sophisticated understanding of mathematics, astronomy, and geometry. The deliberate orientation of these monuments suggests that ancient societies viewed human activity, societal organization, and cosmic phenomena as deeply interconnected. By aligning structures with celestial events, these civilizations imbued their constructions with layers of symbolic, spiritual, and functional significance, transforming architecture into an instrument of both cosmic observation and cultural expression. Social organization was essential to the creation of these monumental structures. Coordinating large workforces, managing scarce resources, training skilled artisans, and sustaining construction over decades or even centuries required highly developed administrative systems, hierarchical leadership, and meticulous logistical planning. Ancient societies demonstrated the capacity to orchestrate multi-generational projects with remarkable precision and consistency. The integration of social organization with technical expertise underscores the sophistication of these civilizations, showing that their monumental achievements were the result of careful planning, collective intelligence, and cultural ambition rather than brute force alone. Large-scale constructions became symbols of societal cohesion, technological capability, and cultural identity, reflecting a deep understanding of human coordination and resource management. Durability and resilience are among the defining characteristics of these ancient constructions. Many have withstood earthquakes, floods, erosion, and the passage of millennia while maintaining structural integrity and, in many cases, alignment with original celestial or geographic markers. Builders employed advanced techniques, including interlocking stone construction, careful weight distribution, and stable foundations, to ensure longevity. The enduring nature of these structures demonstrates foresight, technical skill, and practical intelligence, reflecting a vision that extended far beyond the immediate needs of the civilization. Their resilience is a testament to both intellectual mastery and visionary planning, illustrating an understanding of construction principles that remains impressive even in contemporary engineering. Cultural and symbolic meaning was embedded in these structures from conception to execution. Many incorporate sacred geometry, celestial alignments, and symbolic motifs, conveying religious, philosophical, and societal principles. These constructions were intended not merely as functional or ceremonial spaces but also as repositories of knowledge, cultural identity, and spiritual significance. By blending technical precision with symbolic intent, ancient builders created monuments that were simultaneously functional, ceremonial, and intellectually profound. Architecture became a medium for transmitting knowledge, reinforcing social cohesion, and preserving cultural values across generations. The integration of art, science, and spirituality reflects a worldview in which human activity and the cosmos were interconnected, revealing a cognitive sophistication often underestimated in traditional historical narratives. Encountering these megastructures evokes awe, wonder, and profound reflection. Observing massive stones cut with extraordinary precision, interlocked in complex geometric patterns, and aligned with celestial events inspires admiration for human ingenuity. Simultaneously, these achievements raise questions about lost knowledge, forgotten technologies, and civilizations whose extraordinary capabilities appear to have disappeared from historical memory. Recognizing that societies thousands of years ago could accomplish feats still difficult for modern engineers forces a re-evaluation of conventional assumptions about linear human progress. These constructions suggest that human history is punctuated by extraordinary bursts of innovation and achievement that are often obscured, forgotten, or lost over time, leaving behind tantalizing clues for future generations to uncover. Ultimately, hidden ancient megastructures demand a profound reassessment of humanity's past. They reveal civilizations capable of advanced engineering, astronomical observation, social organization, and cultural sophistication far beyond conventional expectations. The scale, precision, and global distribution of these sites indicate that human ingenuity existed at levels far higher and far earlier than mainstream historical accounts suggest. Each megastructure stands as both a testament to human achievement and a challenge to prevailing assumptions, encouraging exploration, study, and reflection. These constructions illuminate a past rich in knowledge, foresight, and capability, revealing a history far more intricate, complex, and extraordinary than conventional narratives allow. They remind us that our ancestors were not primitive but possessed remarkable intelligence, creativity, and vision, leaving behind legacies that continue to inspire, challenge, and expand our understanding of the ancient world. Across the vast stretches of human history, hidden ancient megastructures continue to inspire awe and ignite debate among historians, archaeologists, and engineers. These constructions, found across continents and often buried beneath centuries of earth, sand, or vegetation, are far more than mere monuments. They represent the extraordinary ingenuity, technical skill, and visionary thinking of civilizations long forgotten or largely unknown. Unlike ordinary ruins, these structures combine monumental scale with remarkable precision, planning, and knowledge, demonstrating capabilities that modern scholars still struggle to fully comprehend. From the highlands of South America to the deserts of Egypt, from the rock-cut temples of India to the ceremonial terraces of China, these constructions reveal that ancient humans possessed an advanced understanding of engineering, mathematics, astronomy, and material science, creating legacies that continue to challenge conventional timelines of technological development and societal sophistication. In South America, the Tiwanaku complex and the enigmatic site of Puma Punku in Bolivia provide some of the clearest evidence of early civilization's extraordinary abilities. Puma Punku, in particular, is a site of unparalleled complexity. Massive stone blocks, some weighing more than 100 tons, are cut and interlocked with precision that seems almost impossible using the tools traditionally attributed to the civilization that built them. Many stones exhibit perfectly straight edges, right angles, L-shaped and T-shaped configurations, and cylindrical holes drilled with uniformity, demonstrating a profound understanding of geometry, material properties, and engineering principles. Transporting these colossal stones from distant quarries, moving them across rugged terrain, and placing them with meticulous accuracy would have required not only immense physical effort but also sophisticated logistical planning, coordination, and possibly technologies now lost to history. Modern experimental archaeology has attempted to replicate these feats using stone hammers, copper chisels, and basic levers, yet these attempts consistently fall short of matching the scale, precision, and efficiency achieved by the original builders. The sophistication of Puma Punku reflects a civilization capable of combining abstract reasoning, technical skill, and visionary planning to create structures that are functional, enduring, and monumentally impressive. In Egypt, the Great Pyramid of Giza stands as one of the most remarkable testaments to ancient engineering and planning. Constructed from millions of limestone and granite blocks, the pyramid exhibits extraordinary precision in alignment, leveling, and structural engineering. Its base is nearly perfectly aligned with the cardinal points, and its internal chambers are designed to withstand immense weight, remaining stable for thousands of years. Ventilation shafts are aligned with particular stars, indicating that astronomical knowledge played a critical role in architectural planning. Conventional explanations, such as the use of ramps, massive labor forces, and simple levers, struggle to fully account for the speed, accuracy, and sophistication of the construction. The Great Pyramid exemplifies not only practical ingenuity but also intellectual mastery, reflecting advanced surveying, structural understanding, and organizational capability. Beyond serving as a tomb or monument, it embodies a civilization's capacity for abstract thinking, precise execution, and long-term planning, offering a glimpse into a culture whose technical achievements continue to defy contemporary understanding. In India, the rock-cut temples of Ellora and Kailasa further illustrate the extraordinary achievements of ancient builders. Entire freestanding temples were carved directly from solid rock, forming interiors and exteriors of exceptional intricacy and structural stability. These constructions required meticulous planning, profound knowledge of stone properties, and mastery of geometry and load-bearing principles. The precision, scale, and complexity of these works suggest a civilization with advanced engineering and mathematical skills, capable of executing projects that modern engineers would find challenging even with today's technology. In China, ceremonial platforms, terraces, and urban complexes demonstrate similarly advanced technical capabilities. They feature precise leveling, interlocking construction techniques, and alignment with cardinal directions and celestial phenomena, revealing a sophisticated understanding of surveying, astronomy, and architectural design. The recurrence of advanced construction techniques across geographically distant civilizations raises important questions. Did these innovations emerge independently in isolated cultures, or was there an exchange of knowledge along ancient, largely unrecognized networks of contact? Either scenario underscores the extraordinary capabilities of early human societies. The technological sophistication necessary for these constructions continues to baffle scholars. Archaeological evidence of specific tools or methods is scarce, leaving much to speculation and experimental reconstruction. Replications using primitive tools consistently fail to reproduce the precision, scale, and efficiency of the original structures. Some researchers hypothesize the existence of now-lost techniques, including mechanical methods for moving massive stones, chemical or physical processes to manipulate materials, or advanced surveying and measurement devices. Whatever the case, the results are undeniable. These structures exhibit complexity, accuracy, and durability that remain extraordinary even by modern standards. They are not merely feats of physical labor but the product of intellectual mastery, practical problem-solving, and long-term strategic planning. Astronomical alignment is a defining characteristic of many ancient megastructures, revealing the integration of scientific observation, ritual, and architecture. Across continents, many constructions are deliberately oriented to correspond with the positions of the sun, moon, and stars, marking solstices, equinoxes, and other significant celestial events. Achieving such alignment required long-term observation, precise measurement, and careful implementation during construction. This demonstrates that these societies possessed not only advanced engineering skills but also a deep understanding of mathematics, astronomy, and geometry. Aligning structures with celestial phenomena reflects a worldview in which human activity, social organization, and cosmic cycles were intimately connected. By incorporating astronomical knowledge into monumental architecture, ancient civilizations transformed their constructions into functional, symbolic, and spiritual instruments simultaneously.